Please because okay. So as okay. So maybe just to check, Anne, you do have access to Microsoft. You're set on Microsoft Work account. Yes, with your work email, and you have access to that today. Awesome, awesome. Okay. So as we get started, I'm just working on the setup there, so we can begin in earnest. And how many of you have heard of BigQuery, Google BigQuery? Awesome. So when we talk about Microsoft Fabric, on the other side of Google, if you're thinking of, stacks for data professionals, BigQuery is the equivalent on the Google side for Microsoft Fabric. And Microsoft Fabric is relatively new. I think less than 2 years old now. And today we want to get to just the depths of how Microsoft Fabric solves the different challenges that data professionals face in their, day-to-day workflows. Okay. So I think we can begin. And just to give you an overview of what we want to cover today, it will be 3 sessions, but the core of it will be the first 2 sessions, where initially I just want to introduce you all to the idea of Microsoft Fabric, so that we all get to appreciate, what is Fabric, why is it really important for anyone in the data space or anyone dealing with data. So that will, encompass just looking at the challenges that data professionals face in their workflow. Maybe some of you will also tell us some of the challenges you faced as an individual And we'll also get to introduce the idea of Fabric, what it really is, what it then solves, and the highlights you see with an asterisk there, like setting up Fabric, will be more of lab-based. The only challenge or proviso that I would make is Fabric requires some bit of licenses, which hopefully we get to set up on all of our machines, but to the extent we won't be able to, I think you'll build with me. I'll build as we go along. And for those who have access to work emails, then you'll be able to set them up on your side. And depending on our seating arrangement, we can, share in the experience. So hopefully we get a good distribution of the same. And maybe just for a confirmation, besides Anne, who else has access to a Microsoft Work account? Maybe just by a show of hands. So we do have yourself. What's your name? Caleb. And anyone else? So it seems this side of the table we are lucky, but anyone from that other side? Just besides Anne? It's okay. Yeah, go for it. Yes, yes.
I already existed, right?
You already existed, yes?
My trial period, so I didn't.
Wow.
Yeah.
You also have access. Let's see how we'll cover that.
I'm still trying to understand what you're saying, like access to the Microsoft.
So, what's your Microsoft account? Is it a Gmail-based account?
It's our thing.
Then we are set on that side. I'll set you up. I'll take you through how to, just set up Fabric and run up your capacities.
But I hope there's no stepping on that.
No. It's all cloud-based, and it's all within the Microsoft ecosystem. So no elevation required for any external app installation. So it's going to be good in that sense. And your name? Nicholas.
Yes.
Yeah. Okay. So we have Caleb and with an asterisk, and Nicholas who have access to a Microsoft work email, and I think that will work for now. So we'll set up labs. We'll work with the different Fabric persona. So if you're a data engineer, if you're a data analyst, like I said myself, I'm a data scientist, so I have a bias. Hopefully, we don't get to see that coming out too much. Then we'll just get to the interface of what Fabric is, the workloads, the different workloads, what you can do with it. And we'll also test an example of how we can get in data to Fabric and maybe do a few queries here and there. But core to the idea of Fabric is also the OneLake architecture, which I would want to dive deeper into just to get you to appreciate why it is core to Fabric. And then lastly, I can show you maybe a few experiences here and there, for example, as a data analyst or as a machine learning engineer, what you can do with Fabric. So that will conclude the first session for us. And then the second session, which will be done or led, facilitated by my colleague, Victor, will be to now, create a report, ingest data, and just a build-up on what we've already covered at the first session. And as promised earlier, you will get an assignment, which you will, go and test or try by yourselves, and hopefully that will get you either interested in data if you're already not in the data sphere, or will get you to just appreciate what insights, what results you can get from data analysts. So with that in mind, just to set the stage, I think by now all of us have used an AI tool in one way or the other, maybe as a data professional or just in your daily workflows or as a student or for random stuff. So for example, if you're stuck in traffic and you want to know, some random searches, you've used Gemini, you've used ChatGPT and the likes. But at the core, because AI is becoming the differentiator for businesses. I do a lot of consulting, and most businesses, from a risk perspective, they are very much concerned on, are we going to be ready for the next phase of competition? So if you're, for example, in the professional services space, if you're in the banking space, these companies are asking themselves, what are we not doing to be like the others when it comes to AI adoption? And what is coming out really, more pronounced is that leaders themselves are concerned about the value they're getting from the AI cycle hype. They're also looking to invest more in trainings for data. This is through surveys done by different professional services companies. EY has done a survey. I think KPMG already also did a survey, and from the 2023 PwC survey, which I've also seen a new one for 2025. If you can read around, even Kenyan CEOs, East Africa CEOs, and leaders and business leaders are more concerned about being left behind the curve, and their goal is to now invest in data. So what that means for any data nerd or somebody who's just interested in data, which we'll talk about the different professions in data, in the data space in a few slides. What it means for you is the opportunities are now abound, and it would be disadvantageous if you don't jump into the data train and capitalize on it, either from a business standpoint or from an individual point of view. But then one of the reasons why we have tools like Fabric is because you've had this cliche phrase that garbage in, garbage out. So even for data systems, if you train it with garbage data or poor quality data, then you just get poor quality results. Why do you think maybe Gemini works better for queries that are more recent than other tools like Perplexity or ChatGPT? It's about the data with which they've been trained. Some of them, and data quality measures are things like validity, there is the format and such like things, but even recency. So if today I have a query about maybe the next Google phone, and my AI program was trained on 2 months worth of data back, or maybe data up to January or data up to even April itself, it won't have that sort of result. So recency is still a quality measure for data. And some of the problems that we have with these models result from the root cause, which is the quality of data through which they've been trained. And so even as businesses, they can't adopt AI, they can't adopt analytics to the level they need to be, because there's an analytics cycle. You move from just descriptive analytics, getting to know what happened, in which areas of the business it happened, when it happened, and all that, to predictive analytics, where you start asking or answering the questions of what will happen if we do AB? What will happen in the next 4 years? What will happen in the next 4 days, 4 months, or whichever time period you're working with? That's more of forecasting. Or what will happen if we give these people this product? What will happen if we give these people loans? What will happen if so predictive analytics. But then in the cycle, you also, once you've achieved some good level of maturity on predictive, you move to prescriptive analytics, where you're now able to evaluate, okay, if we put this intervention, how likely is it going to, solve ABCD? So the main deterrent to companies moving up that cycle is the problems that we are about to just reflect on in a few slides. And there are modernization efforts just to enhance the quality of data. I think anyone who's worked on the data side, on the data architecture, data engineering side of things, it's all about giving quality data to those who need it, so that the end goal is to derive insights. Because at the end of the day, if you're working in the data space, you're rarely the end consumer of these reports or whatever analysis you do. You're mostly driving a decision, and you're making a case for some investment, or be it resource or time, or whichever, to be made to act on your recommendation, which is supposed to be data driven. So for you to make a tighter case, you obviously need to have reliable information and reliable data. So I know I've mentioned a few examples of roles within the data space, but maybe I've only touched on data engineers so far, which we are so lucky today to have one. And she'll also get to just tell us, what she does in her role as a data engineer. And I'm sure some of you are also data professionals in whichever way, maybe role agnostic, and you could be spanning some of these roles, or you could be wearing, the hat of a data engineer and the hat of a data analyst at the same time. So just so that it doesn't get you don't get too monotonous or too bored with my voice, I just want to also hear from a few of you, so that I know, okay, we have Caleb, we would have anyone else. So I would also want to, just get to hear from yourselves. So from the far end, if you can give us any other role or any other role of a data in the data space that you've heard of apart from a data engineer. So a data scientist. And a data scientist, what do they essentially do? Is mostly focus. A data scientist is wearing the hat of a data analyst and also more of a machine learning engineer, is it? So they're in the middle of that analytics curve. They are more focused on the predictive analytics side of things. So you're trying to answer the questions of, there are three fundamental problems in data science or in machine learning, which is answering regression problems, clustering problems, classification problems, and forecasting problems. So I would say 4 maybe, but you can look at it in that sense, where you want to ask, okay, if I give you this loan, are you able to repay it back? That would be more of a classification problem, is it? But what if we are dealing with something like, what's the credit score of Caleb, given his historical transaction and demographic data? What kind of model are we talking about there? Regression model. So a data scientist more or less wears the hat of a data analyst and a machine learning engineer, which is a very common role. But I think I also want us to just reflect, because now I've mentioned a data analyst, we've mentioned a data scientist, but we also have people we rarely hear of, roles like data strategists. So data strategists, they mostly define, the architecture, the use cases for data within that organization. They define, it's more of, they define the strategy that will be anchored on that data. We also have, sorry.
Before you move on,
Yeah.
what's the difference between a data strategist and a business analyst?
A business analyst mostly interprets they kind of connect the business context to the data context. So they're a bridge between core data professionals and the business itself. So I would say a business analyst is closer to a data analyst than they are to a strategist. Strategy, your thinking matters. How are we going to store this data? How are we going to use it? And what value are we going to derive from it? Why do we need such data? And of course, when you're looking at things like privacy rules and all that, you also have to think about compliance. So how are we going to use this data? What data do we need to collect, etc. So the data strategist thinks, or their role is to kind of have a full picture of how data will drive the outcome of an organization.
So someone who works in data governance can also work as a data strategist.
Yes and no. I think a data governance specialist, which is a role in itself, is closer to a data steward than to a data strategist. Yeah.
Did you really technical, the strategists?
Yes, strategists. Well, they might not be, writing some of these platform requirements and architecture, but they have to have knowledge of. So, for example, if you're going to recommend Microsoft Fabric, you really have to know the end-to-end use cases for this fabric. So you're going to have an idea. And they tend to be mostly senior people who've already worked in other data roles, so that they have an idea of what are the needs of the different data groups or groups. Yeah. Understood? Yes. So a data steward is now less technical, frankly speaking, and they do more of the data management, data governance side of things, where they define things like the principles around managing this data. They define the compliance rules. They define, those sort of triggers, etc., that would hinder either achievement of the strategy or that can promote, general data compliance around. So it's closer to a data governance personnel. We also have BI analysts that, like we've said, and sometimes we underlook this role, but it's actually very important because you can shout all you want, you can build all the complex solutions as data people, but if the business is not feeling the ROI on that, I mean, it could be discarded. Your report could be misinterpreted. Your report could, so they help connect the needs of the business to what data professionals are doing. And of course, a BI analyst in this case is closer to, in the software side of things, a BI specialist. But the only difference in the data side is they're mostly looking at the data stack. And we do have a few other roles, but even a data consumer is a professional in the data space. And a data consumer doesn't have to be interacting with tools and some of these, they don't have to have all these skills or even some of these skills. They just need to know this is the end result of what I'm looking at. We even have data product managers, they kind of own the chain. And a data consumer, your CEO could be a data consumer. You know, your functional manager could be a data consumer. Even us as external parties to a company, we are data consumers. So in the event that you choose to lie with statistics, for example, or either knowingly or unknowingly, you've misled someone in the data space. You've misled the consumer. I've mentioned other roles like data product manager. Any other that I've not touched on that maybe you've heard of?
There is from now the non-profit side.
Yes.
So we have monitoring
And evaluation.
accountability and learning.
Mm-hmm.
So it is also being divided. I can see because you can see maybe just one and accountability officer or just an evaluation officer.
Yeah.
But now for these middle people, I think they begin now from the one go. So they just don't find like the data just being collected, but they're the one now deciding like how we're going to collect this data.
Mm-hmm.
Then they go forward and then analyze it. And then there are also these people that the other thing is information management.
Yes.
So in the side, you see like information management maybe it is some
Cyber security related. Yeah.
But when you go to the side, now you try to look at to do activities, just find like this, then normally just
Absolutely. And like I said earlier, I'm a trained statistician, so that's what we did in campus. But you realize you can never, or you can no longer be a valuable statistician if you're not working with data. Another role that I maybe forgot to add on this was more of a data storyteller. And I read a research paper somewhere. I've forgotten the name, but the whole message of that article was, yes, we sometimes do very good analytics. We do as data analysts or data visualization specialists, which can be a role in itself, or data analytics engineers. We do so good of a job, but sometimes we don't get to communicate to the audience. They could be data consumers or even fellow data professionals in other teams. We fail to communicate the result, the end goal of our work. And in most cases, your report, your end result is what kind of gives a pointer to the level of effort that you put in your analysis, in your data collection, or whichever process you are involved in that whole data life cycle. And so if it doesn't sing a good song, then it doesn't get appreciated by the people who might need to appreciate it. And that's where also data storytellers come in. They come in to bridge the gap and kind of make or bring interest to the work that data analysts and data professionals do. Sorry for that, I don't know. So within that whole, sorry, my apologies. It seems this is not on. Could you check from there? Okay, now it's back. Probably should have confirmed but I hope we don't lose connection. For those online, apologies, just a slight technical issue, and coming back in a few seconds. Thank you, Crispin. So yes, ability to actually influence people. I always, it's a quote that I think summarizes the role of a data storyteller so well. I always say facts will get recorded, but stories, if you are able to associate your data report or your output with a story, it gets remembered. People and if you think about it, our civilization and most things that we hold dear are actually built on stories. Stories bring people together. Stories influence people to do things. Stories influence people to on um, act on a message, and that's why the role of a data storyteller is very critical to the strategy. I mean, the data strategy for an organization. Okay. So for anyone online, please confirm that you are not able to see my screen. Just dropped off a bit there. Okay. So let's now reflect on businesses. What's the main problems that data professionals face? One is disparate data systems. So some data is sitting in maybe an Amazon S3 bucket. Some data is sitting on your laptops. Some data is sitting on your OneDrive folders. Some data is sitting on a BigQuery database, and we get what we call like siloed data experiences, which is also even exacerbated by the differences in the formats that we use. Some teams would like to use maybe JSON data. Some teams would use CSV. Some teams are writing their data to XLSX or whichever other format. And this creates the problem of, as an organization, for example, Equity Bank, you're not able to use all your available data to drive the decisions that you need. So Equity Bank, maybe you'd have access to Finacle, right? And sometimes some other data is sitting on your local Oracle database. Some other data is sitting with the loan appraisal specialists, for example. So because of this disparity in where this data is stored, whoever is doing the analysis, be it the data scientist or the ML engineer who wants to maybe develop a model to predict credit scores for loan applicants, is not able to kind of gather it together, either in real time or even otherwise. And with that, these differences, even in the data formats, they're not able to, or they take a lot longer to integrate it into their systems or into their workflow, right? Then the other problem is also poor quality data. So that is to say, there is no standardized formats, there's no standardized data quality checks that exist within an organization. And so you spend, and data scientists themselves will tell you, they will be spending enormous amounts of time just screening the data that is handed over to them, maybe by the data engineers in the room. So with that poor quality data, then the process is just slowed down, and that is becoming a deterrent in the end goal of achieving full analytics maturity and capability in any workflow or any organization. Then the other problem is maintenance, technical requirements. So for example, for you to provision, a server or even a data storage, there's just so much technical knowledge required. There's so much, there's a steep learning curve, and not everyone who is supposed to actually be including data analysis into their workflow is going to benefit from just the availability of data. I also work as an internal auditor. I've seen HR professionals, for example, anyone in business needs to integrate data into their decision-making processes, right? Even if you're a sales agent, you need to analyze or have some basic level of analytic skills to actually drive what you do. And there's no better person to do the analysis for you than, you as whichever role, let's say even a photographer, because you know your data best, you know your features, you know the end result, you know what you need best. So if you don't have the technical expertise to even set up your data systems, how they're going to be integrated, then there's really a lot of friction. Data governance and data security risks is a big problem. When we talk of regulatory standards, especially for those in the regulated spaces like banks, insurance, and the likes, you will always be getting audits, and your data storage systems will, the architecture will have to be audited. They will have to be reviewed from time to time. Who has access to data? Who should not have access, and all that. So, because of these different silos in which we have information stored, even data governance and data security becomes a challenge. If I leave this department today and I go to another department, who will be tasked with revoking my access to Gmail, my access to AWS? So that sort of jeopardizes the organizational data management and data governance practices. We also have very many technical platforms, an example of which you'll see in a few slides here. Like, for example, just even the Microsoft ecosystem itself. We do have so many products, and they all require different technical skills. So, for example, how many have worked with Azure, the Synaptics engine? How many have worked with Spark, Apache Spark? Yeah, for the data engineers in the room, I'm sure, and even for ML engineers, I'm sure you've interacted with that. But having to learn all these different products or stacks, and the next day maybe they are obsolete or they've been deprecated, is such a pain for data professionals. So that kind of, again, limits interest in data. So whenever you talk about, we are about to build some small data model to just, tell us what amount of inventory we should order if you're in a hospital, for example. The first reaction is not, yes, let's go for it. It's more of, what do we need to do? What data models do we need to build? What data do we need in this case, and where will we store it? How much storage requirements do we need for the same? So it's a friction point for adoption of analytics, but even to a degree, the extent to which you can build AI platforms on your data with your existing data is also dictated by just the availability and the appreciation of data across board. So if you think about it, most organizations are here. We do have different teams, maybe several business teams, and a number of data teams that are focusing on different things. Some are doing the modeling, and they would therefore have access to different sources of data, which again is a problem in itself because you therefore don't have unified results. If you're accessing a trial balance as of yesterday and it's been updated today and all those sort of things. So it creates a lot of inefficiencies. And then other problem is if we have data stored, let's say, in our database as this analytics team, and you guys need it, you'll have to copy it from our end and push it to your database so that you can start working with it. That's typically or generally what happens. The problem with that, you have a lot of redundant data existing in different data storage systems, and their consistency tends to differ. Managing access to such becomes a challenge. Hence, you're exposed to data privacy and even data access risks. And then there is also limited interoperability. So, okay, this team, we tend to just work with Excel data, and it tends to be more of the business analyst side, because then they just need quick, dashboards from either Power BI or Excel. And this team, because you're doing more of machine learning models, you're doing, some prescriptive analytics, and to that degree, you're doing some AI models. Maybe you've opted to be working with CSV data, and so it becomes a challenge to get the same data to be used across board. There's a role we didn't mention, which is called the Chief Data Officer. And maybe they work hand in hand with data strategists. So this slide, as you can see, the intention is not so that you can, zoom in and start investigating all of these data products. The whole goal is to illustrate that data's chief CDOs are nowadays complaining that their role has become more of a data integration role. You are always integrating this data, just so that you can have a solution. And the challenge with this is, yes, you might be having, AWS today and Microsoft, but then you realize that for your visualization, you actually need Tableau, right? So you have to integrate that into your ecosystem. Again, comes with data security risks and data access issues. And then you realize that the formats that Tableau supports are not even supported by whichever platforms you've chosen. You've chosen like an IBM DB2 database, for example, or Cosmos database, or whichever. So their role becomes more of, yes, I'm able to source this tool. This is cheaper. This database is cheaper than this other one, but this is better for real-time compute. I can get this other engine to analyze my data. I will be using, I don't know, maybe R for my data modeling, etc. And so it becomes a jumble of different tools requiring different skills and limited scalability. Because if you now need to work with, let's say, high velocity, high veracity data, then maybe some of these tools are again limited in that sense. So because of just the sheer number of products that exist and the differences in formats and standards that they have, chief data officer roles are becoming challenged, that they need to have an integrated system. Now you can decide, fine, I'll go with one platform. I'll go with Google. Google will have, the BigQuery tech stack, and then suddenly you hear Google still has, maybe Google Colab is not included within BigQuery. Then you realize that some other Google tools themselves are not included within that BigQuery structure. Same to Microsoft, they are still not off the hook. The problem, you have Purview for data governance, because here you want to monitor who has access to what, at what point should the access be revoked, etc. But then once you need to create your reports, suddenly you have to learn Power BI, you have to work with Synapse, like I said earlier. And so we have a problem of many products, they have different experiences, and for those who've been in the Microsoft space, maybe you've been working with Windows, you saw the difference between maybe Windows 10 and Windows 11. The whole goal was, even from a UI perspective, you should be having similar experiences across different tools. So if I can open a tab, a ribbon on my notepad, then I should be able to open the same on maybe Microsoft Word. If I have access to files, if I can bring in Copilot in Excel, I should have the same experience in my PowerPoint, for example. So always you want less variance in the experience, in the user experience, because it even builds on muscle memory. Some of these tools, you will notice, are built on open source systems or open source standards, and some tools are proprietary. So you will get to maybe know that, maybe the primary file system for Google, you realize is maybe Iceberg, right? And then when you go to AWS, it becomes Delta Parquet files. So you can't move your data across, for example. Even within the Microsoft tools previously, for Azure, you needed Delta Parquet files, which we'll talk about. But then for Power BI, it doesn't work with those files. It only works with Excel and a few others, like CSV formats. So that variability in the standards, the formats, and even experiences, it limits the adoption process. Some are dedicated, so you have to provision on your premises, on your on-prem or within your own systems. Some are serverless. So there's disparity and there's differences. Some are software as a service, some are more of platforms, and we have steep learning curves, which require deep expertise in different tools. And now that's where Fabric comes in. So Fabric, and this is now where we start talking about Microsoft Fabric. So we were just still introducing the idea of data, the problems in data, the different data professionals and what they do, some of which we'll explore within Fabric and how they can now leverage Fabric. But Fabric has been brought to solve those problems that we've talked about. So the problem of multiple analytic services. So in maybe you used to do your data engineering notebooks with, you used to run them on R or Spark SQL, or Python PySpark, and you're running your reports on a different platform like Tableau. So it's to bring that unified stack. And you will also notice, which is something we want to explore within OneLake, that data is now existing in a single source. Data is all in one place, which is called OneLake, so that if this team needs the data, if this other team needs the data, and this other team needs the data, they don't have to copy it to their workspaces. They don't have to copy it to their machines or to their servers. They can all just access it from a single source, something which we'll demonstrate in a few. The problem we've seen previously of different applications like Purview, you have Power BI, you have, I don't know, Data Factory for data engineers and data warehouses, all those different things being, different experiences. It's all been now unified so that you just have what we call workloads, which are applicable to different professionals, a point to which we'll visit. So you will notice that Microsoft Fabric is more of like an end-to-end data analytics solution. That is to say, it's useful for all data professionals, data consumers, BI analysts. They all have something they can do within the platform, and they can all access the same data, and they can all access the same analytics engines or whichever compute engines. Then it's also cloud-based. That is to mean you're not limited by the resources of your computer. Even if today you're using a Core i2 and somebody is using an i9 or somebody is using an M3 Max machine, you'll have similar experience as long as the internet connectivity is the same, because it's all cloud-based. Then it's also serverless. That is to mean you don't have to, do any provisioning. All this is managed for you. So we're just working with what we call capacities, and the load will be balanced based on the requirements that you have, either as a single analyst or as an organization. So all that work of, provisioning the software, managing the build and managing the resources and the infrastructure has been done for you. Your focus as a data professional is just to come in and do what you need to do. As a data engineer, you come in and, put your pipelines and configure your different data flows. You hand it to the next person to do what they need to do. As a BI analyst, you just come and develop your reports and you're good to go. As a machine learning engineer, you don't have to worry about setting up your whichever stack, setting up your servers and databases and all that. Your role is just to focus on what you need to do. I need to write reports. You can actually build reports from, Power BI and the likes, which we will explore. So that disparity and differences in different applications has all been brought under one roof for you to focus on driving or deriving value from the data. Then it also has GenAI capabilities built in. Again, this is activated based on the different licenses that you have. How many have used Copilot, Microsoft Copilot? Yeah, so GenAI is becoming the new thing, the in thing for, just speeding up your workflows, and it's built within these workflows. So this is, I would say, the architecture of Fabric. Yes, it would look different depending on, in terms of just the icons, but we do have what we call workloads. So data factory, data engineering, data warehouse, data science, real-time intelligence, databases, Power BI, and then there's something that is in preview for bringing in, other workloads, which I think right now, when we explore Fabric itself, we'll get to see some of them. So what this means, and don't worry, all these slides and all materials will be shared with you. I think Nduti, we can work on maybe sending like email. Yeah, so all this will be shared with you. And these slides, you will notice something. I do have a lot of notes just to also help you internalize some of them. So when you're reading the slides or the material, feel free to also just go to the notes section to get the in-depth understanding of all of these areas. So with Fabric, there's something we call a persona. So as a data engineer, there are just a few things that you will be using within Fabric, is it? And you will therefore wear the hat of a data engineer, and that would mean you will maybe interact with data factory, data engineering, and data warehouse, and maybe that's where you leave it. As a data analyst, you might rarely interact with data engineering or data warehouse or even data science. So you will just interact with data factory and Power BI, for example. As a data steward, you might just interact with, the security and governance layer. As a business analyst, you may just interact with BI, Power BI only. As a data consumer, again, you will just interact with the reports. As a database administrator, you will maybe interact with the data factory and databases. So it's an end-to-end solution to cater for different data persona, but it has commonalities, one of which is Copilot is built in. The other, which is the most important, is the OneLake, the Microsoft OneLake architecture, which we want to dissect it further. We want to understand things like what's a data lake and what's a data warehouse, and what is OneLake, for example, and what is a data lake house. So we want to explore all those because it's one of the core of Microsoft Fabric. Just so you satiate your curiosity, OneLake is the data storage element of it. So what I kept saying, like data engineers, they need the same data. Maybe data analysts, they work with the same data. We'll get to explore why that is important, because if we have data being stored here and the other data somewhere there, and all this in different systems, you've seen, or we've talked about the risks associated with that. Risk is maybe lack of integrity in the reports, lack of access controls, and data governance measures, and compliance issues, and so on. And then we also have Microsoft Purview, which is now to mean you want to manage access to these workspaces or to this data in a unified manner. So if this team is supposed to access this data, you only have one single area of managing that access. Even if that data is stored somewhere in an S3 packet or in GCP, or in, I don't know, maybe Snowflake database, because it's going to be connected to OneLake, you only need to manage that access from a OneLake angle. So that's what we want to explore. And with that said, before we get into the platform, just a summary of what Microsoft Fabric solves. That lack of access to quality data is solved by, we now have OneLake that facilitates organizational-wide data access. So even if it is HR data that is required for the auditors, it's just sitting within the HR platform, and then we manage that access for auditors. If it is transaction data that the machine learning team needs to have, they don't have to move it to their system. They can, they can access it in that sense. And then OneLake has a single data format, which is called the delta packet files, which we want to just look at what those are. And because of that single data format, now every other team can access it. So even if you're in BI, if you're in data engineering, all this is like, if you think about it, let's say we are working with CSV files. If organization-wide we are using CSV files, then it standardizes the format. The only good thing with data packet files is they have additional features beyond, the common standards that we've always been using. And because a bit of it is low code, actually it's a low code or no code platform, it means the adoption of analytics, even if you're in some role that maybe rarely interact with code, you're still able to benefit from Microsoft Fabric. So that makes all the users, all the data consumers, or all the roles. So that's why this is an event or a session for everyone. Even if you don't interact with technical systems, you're still going to benefit from Fabric because it's a low code or no code platform. We also have GenAI, like I said, and most of those tools, because the background of the work in terms of provisioning and even configuring some of those engines has been done for you, it's more of self-service tools. And so you don't have to be like a very deep specialist in setting up, I don't know, like systems and servers for you to just get a Power BI report, So this is the end goal. The end goal is you want these different business teams like sales, marketing, or even HR or operations to use these different models and data wherever it exists, even if it exists in a Google Cloud storage, even if it exists in a database, even if it exists in this many other different sources, they can all just be channeled into one storage location. So the whole goal of Fabric is to get your data estate together. I've been saying a lot of things, but I think once we demonstrate what it really is, you'll get to appreciate why this is important. It's to bring your data all to one place, transform data in a way that helps you build these models and solutions, and then empower everyone, because that's another problem we have as businesses. Not everyone, like when you go to marketing, they might not be using data to the level they need to because of the steep learning curve and the technical debt that we have, right? So you want to empower everyone to actually work with data and derive insights. And lastly, govern and protect your data. So those are the, I think, core 5 goals that Microsoft is, Fabric is aiming to achieve for you. So let's go to the lab section where we want to set up Microsoft Fabric, right? So that we can even explore some of the different workloads and the likes. You'll allow me to sit down. And for those with Microsoft Work account, it will be easy in the sense that you just need to set up on your laptops. But for now, allow me just to walk you through that, just so that you can just also appreciate. So you need to navigate to, let's say, app.powerbi, or in this case, I can even go to Fabric Microsoft. So I can go to the home page and so they always launch, all these things. We have community. There's quite a lot of things, and in the Fabric workspace, you can enter competition to even win a voucher. But just maybe let me put it full screen like that. So within this home, you have learning, where you can go to the learning modules and just access what those are. So if you are a data engineer, you'll see learning modules specific to a data engineer. You can always filter here. So Microsoft Fabric, and then, sorry. Oh, you, okay. I'm moving too fast. Okay. So for now, I'm just on the homepage itself. I've not gotten to the tool. We have end-to-end tutorials, like Microsoft end-to-end tutorials, and these are either experience-based or multi-experience. So for example, you'd have like a data science tutorial, you'll have a data warehouse tutorial, but what I actually go for is some of these other tutorials, so like Power BI, etc. So those are for tutorials, and you can also just make your own learning map here. If you want to learn Fabric, you just search for a learning path. So I don't know why it selected a module. Yeah, but fine. So let's go to Microsoft Fabric itself. And you can always just interact with this page just to know, okay, what's the Fabric roadmap? What is going to be rolled out? Under learning, what is there for you, etc. Okay. So for that. Cool. I think we've all suddenly gotten into the system, hence the slowdown in the internet. Okay, I think phone. So I just said, get to go back. Oops. So you can just go to app.fabric.microsoft.com or app.fabric, and then it will direct you there. Let me just open an incognito tab so that you can see app.fabric. Then I should get access to go to Microsoft Fabric like that. Just a sec. I think there's an internet issue. So for me, I am already set up. That's why Has anyone managed Cullen? Oh, okay. No problem. So once you're able to navigate to Fabric, so let's say you sign in, for example, in this case, if I sign in with my work account, it will tell me, I think I'm already, I don't need to create a new account. And it will take me to the Fabric homepage immediately. So just allow me to, okay, I think this will work still fine. So it will take me to the Fabric homepage. So Fabric homepage will look something like this, where, because for me, I'm within the EY tenant, so you'll see all those details here. It's one tenant, multiple users kind of experience. I'm able to, I'm using the free trial. So you can activate the free trial for now because you don't have to purchase the license, but it expires within 60 days. So once you're able to activate that trial within that tenant, so depends on the tenant you are in. Once you're able to activate that trial, you'll see something of this sort. So you don't have to struggle with the login for now so much. Let's just focus on exploring the workspace, and I hope everyone can be able to see the screen. Can you? You can't. It seems those online also can't see the screen. So let me see how we can try and get them back. Is it better now?
Yes.
Awesome. Okay. So for those online, we've just we've not set up a Microsoft Fabric account yet. It's just that in my case, I'm already using a trial. So I hope now you can see the screen, Crispin. You can just confirm. And if I view my account, I'll be able to see the kind of licenses I have. And so the license I'm using here is my organizational work license, and I'm using the Fabric free trial. So with that, I will have the Fabric home. And then what you also need to see is, if you're using the free trial, you'll see how many days left. So I just activated mine, for example, yesterday. And so I still have 59 days left, right? And then there's this workspace here. So the concept of workspace should not be so different from anyone who's ever used Power BI workspaces. And workspaces are, maybe just to go back to our slide, workspaces enable you to control permissions. So within a workspace, you can set up users, you can control who can access what, you can add objects, and you can even share them across different workspaces. So I'll show you, for example, the workspaces that maybe are open access to our organization. I'll show you workspaces that I created, that I own. And a workspace is like, you know, in your workspace, in your desk, you always have everything. You have books, you have reports, you have your laptop and everything else. So a workspace contains all items. And in this case, it will contain things like reports, it will contain lake houses, something which you want to explore further. It will contain data models, it will contain data flows, it will contain everything. So the first thing is to create a workspace. So in this case, you will see the different workspaces that I have, but even within our organization, we do have all these workspaces that have been created, and a workspace sometimes, so this is coming from Power BI and Power BI Pro, where you'd have different workspaces and different teams would have access to them. So in this case, if I just open, for example, the consulting workspace, what I'll be able to see will be generally just reports. And like I said, within workspaces, you can have folders of stuff, images, whichever. It's like a folder, right? And this is a Power BI workspace. But there is what we call a Fabric-enabled workspace. So within a Fabric workspace, you're able to do just much more than you could do previously within workspaces. So for me to identify that a workspace is Fabric-enabled, you will see a small diamond. It shows, it's working with Fabric content. So for example, in that case, this is Fabric content workspace. So what I need to do is to create a workspace in this case, for example. So to create a workspace, what I'll do is I'll just come to new workspace, and I hope you're following. And then I can decide to have a naming convention. Maybe for my workspaces, I want to start with WP, maybe to denote a workspace, and I can call it maybe Zindua Fabric Day, something like that. Now, I can give a description of a workspace. It's like you're creating a repository in GitHub or something like that. Then you will go to advanced, and then you will choose a license for that workspace. So if I use Pro license, that will be more of a Power BI workspace. If I can use Fabric trial capacity. So this brings us to that concept of serverless that we talked about. You've been given access to, you don't have to provision database, you provision compute. Sorry for that. All this is done for you in a sense that you don't even have to manage workloads. That's why it's a software as a service. So you don't have to manage your infrastructure, you balance the workloads, etc. You're going to be billed as you're using it, or you will have access to a capacity based on what you bought. So for example, it's like CPUs, and you're buying virtual CPUs and GPUs and even storage. So if your workspace is, for example, 2 units, that would mean, I'm not saying that's the case, but that would mean you have access to 4 CPUs, for example, and everyone within that capacity, within that workspace, uses that capacity. So in this case, if we have 10 of us and we're using a single computer, that means you need to ask yourself the amount of work that we are going to load within that workspace. Will it be accommodated by the capacity that we have? So what happens when you have too many users in a single capacity? Anyone wants to give it a try? What would happen in that sense? Does it break down? What happens? Anyone familiar with the concept of throttling? Caleb, you've given me a look that seems like, oh, this is something I've had before.
Okay.
Anyone familiar with the concept of throttling? Go for it. You can introduce yourself and just tell us what's your current role, or where are you in the data space? and also your name, and just give it a try.
I'm writing it firstly. I like on Google Photos, if you exceed your storage,
Yeah.
you can't add more. Also, with this example, you can't add more users, so you be forced to up your subscription.
Almost there. Yeah, almost, but I think let's get another try. But you didn't introduce yourself.
Oh, sorry, I'm Zoe Aika. My current role, I'm getting into the space of computing that now.
And maybe just related to data, which role interested you the most of what we talked about?
I'm still in school, but generally I want to get more into data analytics.
Awesome. More, I think we'll get to explore some of the data analytics workflows that we can explore in Fabric. Vincent?
Yes, so Kotlin
Yeah.
is like there is an overload, but there are so many platforms or systems accessing the same service at the same time. So
Yeah.
it brings a lot of now, can I say lagging? Like, it requires a lot of power to execute the service, the work. So if there are a lot of users in the same system,
Yeah.
so you have to optimize it to enable the whole work to be done efficiently.
Yeah, I think I would say so. Maybe just to use a simple example, if you've ever left your phone outside, or if you've left it in a very hot place, sometimes it will tell you temperature too hot, can't do ABCD. Or if you've used it as a hotspot and you're charging it so the CPU is overloaded, so much so that things will now start taking time to process. So that's throttling, and that's what happens in your workspace. If the capacities you have are not enough for the amount of workload that you're inputting. So in this case, it's a good thing because it means things will just run slowly, but once the load is reduced, then it brings itself up to speed. And that's why you need a fabric capacity. So you'll see most of these things have been grayed out because I don't have premium fabric capacity. I can still use the trial, so no need of purchasing the premium capacity still. Then for model storage format, for now we can just use the small semantic model format, and I have access to different, capacities. I think this is because the way it's configured, depending on your organization, your tenant. So your tenant will be hosted on different regions. Like in this case, I can use the default, which is North Europe. Then I think that will be all for now. So I just need to give it a name. And then within a workspace, now we want to create different items. So to this workspace, I'm calling it workspace Zindua Fabric Day, for example, right? Then I'm able to create within this workspace a number of things. So if I just select the button create, we want to see the different fabric experiences. So for example, for data engineers, we've all talked about how data engineers, mostly their role is to avail data in whichever format to the different users. So it's more of the designing the architecture that enables the data to flow from its source to the end user. For transformation or for analysis, and that's the data engineering workload. So we had 7 workloads, and within each workload, you will see what you can create. So as a data engineer, you can build what we call a data lake house for you to store data, query the data, even build reports on it. You can also use you can also build notebooks so that you can bring compute to your data, a concept which we want to visit more. You can also create libraries where you will configure your Spark compute settings. So I want, a CPU with this RAM. I would want this and this and this. You will set up your library. So for example, I think it's something best explored in real time. But for example, if I needed some libraries for machine learning people, if you need, let's say, TensorFlow, you want to use Keras for your deep learning models, you just set it up in that environment. So it's like you're just setting up your environments. Here, nobody needs to load anything from anywhere, right? You can also configure, different data functions. Then we have the next one, which is the data factory. So I told you earlier that in our visualization here, they looked really good. Like the icons are very pronounced, but depending on your configuration and depending on when you're working with Fabric, the look might be different, but the experience is the same. So for example, for the data factory workload, it's more about transferring data faster, getting access to that data. So you're building pipelines as a data engineer or as a data analytics engineer. How fast can we prepare, transform, and clean our data so that we can hand it over to the BI specialists or to the users of our reports to build reports off of that data, something which my co-facilitator will take you through end to end. Like, how do you build now reports from those models? How do you ingest data at scale? Again, what data engineers do, because you want to establish pipelines, and sometimes you would have refreshers. So when, let's say, you want your sales data to always be updating every morning at 9 a.m. for previous day, you can schedule, those data workflows, and all these other things you can do. You can put copy jobs, you can mirror databases, you can, there's a lot of mirroring you can do. For now, I think we have mirrored database, which is still in preview mode, which is to say it's like beta mode for software, right? So they're still rolling it out. Then for the data science experience, like I said, it's more predictive analytics. You want to detect outliers, you want to predict, you want to run different machine learning experiments and then, decide on which one works best. So you will put your notebooks here, you will define your ML models, and they are all going to be running on the Spark engine. So Spark is open source and it has different languages. So it's a multi-language compute engine. If you are a Python stack person, if you're an R SQL, so we have PySpark, we have Spark SQL, we have all those. So Spark is the engine that powers the compute within Fabric. Then you can create notebooks for data warehousing. Again, we are talking of database professionals here. You're able to mirror, and then for databases, for anyone dealing with data, SQL will be most of the backbone for your databases. Your real-time intelligence. So here you're talking about streaming data. An example of streaming data would be data from anyone, any example? Go for it.
Just trying transaction data.
Yeah, transaction data. So you can decide for real time or batch processing. But I think there's one that we've been. Have you seen these memes of when somebody just creates a Python hello world? There's a number of words that I usually say. Big data, machine learning. There's one more. I don't know if you guys have seen that video. Yes, IoT. So maybe data from sensors, right? You want that to be analyzed real time. For those who are like F1 fans or sports fans, you have telemetry data where data is constantly streaming in based on whatever platform that you're looking at there. And then for BI, which stands for business intelligence, is mostly to create reports. So when you're wearing a data analyst persona, which is what we want to, the hat we want to wear today, data analyst and maybe data analytics engineer, because you're going to, ingest some data. We are going to schedule some workflows. Then you don't get to use all the experiences within Fabric. And that's why I said Fabric is an end-to-end solution for different data professionals or professionals dealing with data. That is to even include data consumers. So once I've created a workspace, then whatever I'm creating within that workspace will be included. So even if it's a lake house, even if it's a data flow, it will be included within that workspace. But something that I mentioned previously, which was very important, was access. So because a workspace is where you also manage access to information. You can manage access here, where you just search people within your organization and you can add them to a workspace. Or the other advantage of Microsoft Fabric is when you have artifacts, like for example, data that you want to be accessed across the entire organization, you can just endorse. So endorsing, just that is to say, this data has satisfied all the data quality metrics, and then people can access it without changing the source data. So you will be managing workspace access here. For example, if in our, okay, I don't know. Oh, sorry. You can add people depending on their email addresses if they are within your organization, like so. So that way you're able to give admin access, contributor access. So that is to say, and if somebody you just want to give them view access, read-only access of sorts, then that helps you manage data security. Okay, and then workspace settings, you can connect it to GitHub. You will provision, or you can even explore. This one, I think I want us to talk about it once we've talked about the concept of OneLake. You can even explore your data items using the file explorer that all Windows people are so much used to now. So if you download the OneLake Explorer sort of extension, then you can explore using File Explorer to your items. They could be in Parquet files, they could be in CSV, they could be folders, they could be images, all that. So for now, our workspace is empty, which is okay, because that's what we want to practice with. But before we even come back to workspace, there's a concept that I talked about, which is very important, which is this one here, OneLake. So OneLake is a data lake house. We want to talk about what that means. So like I said, just so that we can remind ourselves, for Data Factory, it's solving your ETL scenarios. What is ETL? The process to extract, transform, and load. So you're simplifying that. So data factory enables you to unify your data estate. That is to bring all your data under one roof. Data engineering workload, it's mostly to maintain infrastructure that is all based on one compute engine. And then data warehouse, you have separation of compute and storage. And why do you think we are separating compute and storage? It's more for scalability. That is to say, we talked about throttling, right? So when our system is overloaded and we want to scale, we can add more compute resources, and we don't maybe need to add data. I mean, the data side, is it? So you can scale them independently, but then you can also use different formats, not necessarily being restricted to what the engine, if it is a compute and data storage engine all combined, then you're kind of restricted. So you want to be able to scale them independently. And then for data science, I think it goes without saying, it enables scientists and even data analysts, because there are some data analysts that actually do some ML models, maybe not to advanced levels, but you still run some ML models, but you really want to quickly build, deploy, and kind of operationalize those models. To operationalize a model, we are starting to talk about ML ops now. You're monitoring that model, and you're monitoring performance, you're maintaining that model, and you're making sure that, for example, if we run our credit scoring model based on 2 weeks worth of data, like 2 weeks ago, then have we scheduled a way in which we refresh the data source, then we rerun the model, and then we can now predict new use cases. That's why I think for anyone who's taken a loan with a bank, any bank that uses, ML models, you will find that your credit score, your loan, what do they call that thing? Loan limit changes from time to time, and it doesn't change every day. Of course, it sometimes changes on a monthly basis. That's because the model is being run, let's say, on a monthly basis. And the reason why sometimes you can't run these models every day, you can't, for example, train your LLM every day, because the training process itself is resource heavy. The data collection process will take some time. So you want to maintain your models, and the data science workload enables you to do that. Again, we'll explore what that means. And then for real time, we're talking of, I think as the word goes, you want to track real time insights. And then Power BI, the workload is to bridge the gap between the data builders or the report builders and the business. So, like I said, we want to set up a lake house. And before we can set up a lake house within our space, it's important to understand, why are we talking of OneLake? What problem are we solving with OneLake, by the way? Just to check if we are all on the same page. What problem are we solving with OneLake? Data disparity. Yes, that's correct. And I think there's also something that we'll get to, which is the format. So this OneLake is solving the issue of data existing in different silos or in silos, and then also the data disparity, as we talk about. So data disparity is in two elements, right? So the structure and also the existence. But there's also a problem that we are solving, which is access. Because it's within your organization, within that tenant, it's easy to control access. Other than if data is existing in an S3 bucket, and another one is existing in Google Workspace or Google Cloud, and some are existing in some databases. You have to now manage access at those levels. Whereas if you can bring them all to OneLake within Fabric, then you're able to manage it really well. So before we even talk about OneLake, because OneLake is a lake, is some example of a data lake. There's a difference between a data lake and a data warehouse. And for now, I've just summarized what those are. But I think the best article that illustrates this would be this Microsoft article on Lake House, data lake and data warehouse. Okay. So there's this article by Microsoft. Again, all this will be shared as part of the notes, but the whole gist of it is for data lakes, you have structured, unstructured, and semi-structured data. When we talk about structured data, what do we mean? Structured, it has to stay in the same format. So even if it is, for example, tables, all of them have to be tables, right? In data lakes, we can allow, so you will see data lakes have more flexibility than data warehouses, but also data warehouses have their own place because of those restrictions. It's best for certain applications. So for example, a data lake supports both relational and non-relational data. A data lake is schema on read. So that is to say, the schema is defined when you're reading the data. But this other one is schema on write. So it has to follow a specific schema as you write the data. In a data lake, you can put anything. Everyone just dumps their thing in a data lake. Like all people can dump their data in a data lake. So the sources of data for a data lake could be IoT devices, streaming data, anything. But for a data warehouse, because you need your data to be structured, it has to be, and that structure will be defined by what the application is outputting. If it's transactional data, we want to show these rows and these columns of, okay, that is to say these observations and these features of data, for example. And on this other side, because once you define your data warehouse, it's very hard to scale. It's a process to scale that. And you will realize that different professionals, so data scientists and data engineers tend to use data lakes because of that flexibility. Whereas for data warehouses, like a warehouse, and you're storing the same structured data, it's mostly for databases, database administrators, database professionals, and even BI analysts. It's very rare to find BI analysts dealing with unstructured data. Can somebody give me an example of unstructured data? Sorry? Yeah, questionnaires would be one. Even a book is unstructured, right? Like there's no structure to a book. Of course, it will be in text format, and that's an example of unstructured data. So the whole data space is evolving so that we can now analyze different, you now even have tools to analyze unstructured data. Now, on top of a data lake, we have what we call a data lake house. And because those data lakes can contain, different kinds of data, you have issues with data quality control, corruption of data, maybe improper partitioning. So it's not the most efficient. And that's why we have data lake houses. So it's like a combination of warehouse and a lake. So it's a data lake house. So there's what we call open standard-based storage. It's like open source standards. So in this case, we will be working with what we call a delta per K file. It's, for example, if you wanted an open standard for data storage that is limited, we would say, let's use CSV format, right? And it addresses, some of those drawbacks of a data lake. So for data type, they are all the same. But in this case, a data lake house supports schema on read and also schema on write. So it's combining both the benefits of a data lake house and a data warehouse. Make sense? And of course, format is anything. In this case, delta format files, which we will talk about what they are. Sources, combining both. Scalability, taking the advantages of a data lake. And that is, of course, I'll share this so that you just get the gist of it. But as you can see, OneLake is built on the lake house architecture, so a data lake house. So it's combining both the benefits of a data lake and a data warehouse. So the way to think about OneLake is for MS365 users, all your information is always going to OneDrive as the storage, right? If you're not for cloud-based storage, you're always taking it to OneDrive. And it doesn't matter the format, because sometimes you've pushed some Excel files there, sometimes you've pushed text files or whichever files, even zip files. So it accommodates all types of your data. That's OneDrive. But OneDrive is for documents. When we are talking about data, Microsoft has built the OneLake architecture. So OneLake allows you to interact with analytical engines. So like SQL for database management, Spark, the compute engine, Power BI has its own, transactional modules, kQuery, the database. So a data lake plus a data warehouse gives you a lake house, which is, in Microsoft's case, I think they just used their naming convention. They now use a OneLake architecture. So this OneLake allows you can distribute ownership, you can have your files, you can have your tables, and you can also connect what we call compute engines to your data. So that is what we want to create. That's exactly what we want to create. We want to now create our lake house so that we can start adding stuff to it. Once we create a lake house, we can add data, we can add whichever things that we want to add later. So you will just come here to either new item, right? Or you can always come to create. So you can come and create. So a lake house will be under the data engineering workload, right? So you'll see different elements of different things as we move along of the different workloads. So within the workspace, I will create it as a lake house, and I can search for it. It's somewhere down here. So this is not persona optimized workloads. These have been categorized by functionality. So if you wanted to store your data, you can decide, I'm just going to create a warehouse. And remember, a workspace can contain everything. It can contain event house, semantic models, which we'll talk about what they are. You can even have your SQL database within your workspace. Because why are we creating workspaces? To manage access, right? And then why are we creating lake houses? To now add our data in a way that we bring compute to the data. So I think it will make much more sense in a few. So in this case, if I'm creating a lake house, I can start with the prefix ls just to denote that it's a lake house. And I will say maybe this lake house, I will call it Zindua fabric. And then for now, this is in public preview, the lake house schemas. I think just in the interest of time, we'll avoid, we can't see the screen. Oh, okay, now it's visible. Okay, fine. So I'll create a lake house like that. So when you create a lake house, there are a couple of things that you'll see. So it's loading the lake house. You'll have the lake house. Okay, I think it's slightly small. Let me try to change my zoom level. Hope I'll be able to do that in a few. Can I just hope it won't require a restart? Is that better? Like, can you see better now? Or I don't know how it can change. Okay, that's fine. Let's work with that. So it's slightly more zoomed in now. And I can even create, full page like that. So within a lake house, you will have tables, and then you can also have files. So files you can add in different ways, which we want to talk about. Then tables, what's a table? It's your basic row, column kind of data. So it's in a way structured data, is it? But we say lake houses support and different formats, and the format that Microsoft is using is the unified format across, which is the delta per K file. And the reason we are using delta per K files, maybe just to preempt that, is the format is, you can even have versioning for that file format. So you can resort to previous versions, you can access different changes, something which you can't do in like a CSV file, is it? Yeah. So within a lake house, you will have access to what we call a SQL analytics endpoint. So this is for you to query the data using SQL. And remember, we said we can write data to a lake house. We can also read data, is it? So for now, I want to, and you can even create subfolders within these files. So what I want to do is I can upload files. There's also something that lake houses enable you to do that solves one of the biggest problems that we talked about in data, which is disparate sources. That is to say, and ownership. With lake houses, we are going to be able to access data in a database, and we don't even have to interfere with that data, and we are not copying it to our workspace. Because the moment you copy the data, we have things like infrastructural costs, we have format issues, we have redundancies. So we just have, if it's an organization of 1,000 people or 100,000 people, for us, we are an organization of 300,000 people. Now imagine if everybody was to create a copy of a file that is 10 GB. So that would be 10 GB times 300,000. So we are now having to pay for storage at a costly level because everyone has to copy a certain file to their workspace, which is not efficient. And of course, if that data originated from Zoe, for example, and she happens to change it and I have the previous version, I no longer have the most updated kind of data. So with Fabric, we have what we call virtualization. So virtualization, you do it through the shortcuts thing. So you can create a shortcut to a file. So you know the way when you create a shortcut to a Windows application or a software, it acts as though it is there, but it's not there. So that's the virtualization that we talk about in data. And I'll demonstrate in a few. But for now, let's upload a file. So to upload a file, you will just come to your Windows Explorer, for example, and then I can go to my documents, data science, and I'll go to Fabric. I think this is fine. Then the labs for one, I can upload that file called package types. So it's a CSV file. That is to say, we can, we can have all different types of files. And then the main thing here is we are able to load this data to a table. So because it's a CSV file, maybe I want the table name to be that, and I will just load it there. So what happens when I've loaded it to a table? So just give it a second, it's loading. And then with data now as a table, I'm able to create Power BI reports. I'm able to, query that data. I'm able to do a lot of things because it's now in table format. So in a sense, it is structured. I don't know why there's throttling on my side. Maybe let me just close some of these applications. Yeah. Okay. Okay. So this whole process of monitoring your resources with Fabric, you don't have those problems because right now I have to know that my CPU is at 40% usage and my memory is there. So I don't know what's the problem, but that's fine. So those are the things that you're trying to solve because it's all cloud-based. Now, I can access this table. I can load it. Anyone who's worked with Power Query? Power Query? Yeah. So here we are going to get a more efficient version, and I would say Power Query on steroids within Fabric. So Nduti will take you through a semantic model and what that looks like, etc. So for now, for example, I want to show you that thing which I meant by shortcuts. So shortcuts in this case means I can quickly pull data from internal or external locations into my either warehouse or a lake house without changing the original data at source or without even bringing it to my workspace. So that helps solve those redundancy issues that we talked about and even data update problems, is it? Because we are able to virtualize the data. We are working with it as though it's in our workspace, but it's really still just stored elsewhere. So you can bring it from, different, you can bring it from a different workspace. So that would be an internal space, right? Or an internal source. Or you can bring it from external sources. So which are the biggest cloud providers or hyperscalers that you're aware of? On the other end, AWS, this table. GCP, Google, right? That other table of two. This table. Azure, yeah. So we can access data from S3, ADLS Gen 2, GCP, and even Azure. Okay. Maybe it's a preference for Microsoft here because they own the platform. But what we want to see is, can we access data in an ADLS Gen 2 storage, bring it to our platform, even work with it without having to, we don't own that data, it's someone else's. They just have it within their storage. They've given us access without having to copy it. Because that means if it changes at source, then it changes. We refresh our data and it changes here. Is that right? So that's what we want to do. So you just click ADLS Gen 2 here, and you create a connection. And then these files will be shared with you, the labs. So that will be lab 2, for example. Okay, I don't know why my mouse is jumping all through. And so within this lab, all these instructions will be available for you. So we'll all share this. What you need to do is you want to create a shortcut to virtualize your data from Azure Data Lake Storage, and you have the connection URL, and all that data has been stored there in Delta Packet for file formats. So we will have this URL. That's what we will put here as a URL. And then it will ask us for a SAS token. Oh, okay. I've already supplied the SAS token, but this SAS token is this. It's is the token for you to, is like a password for that file. So we now have this data. We now have access to the ADLS Gen 2 directory, where we can now choose the different files that we need. So in this case, we just go to, for example, the Delta Packet file format, and then we want to choose the different tables that we want to virtualize to our workspace so that we can work with them. So an example would be, maybe we can select this table cities, and we can select another table, maybe state provinces. I think for now, let's just do those. And of course, you can always select all these other ones. So I'll give you like an assignment to just explore all those other tables. So we just want to bring 2 tables for now. And we can go ahead and create them. You can change their name, but in this case, no point. We can just go ahead and create them. So those tables will be loaded, right? So once I've loaded those 2 tables, I can even go through them and see what it entails. So for example, cities, it's taking some time to process. Remember, we don't even have this data in our OneLake storage. It's being virtualized here. So the main advantage with that is if it changes at source, we just have the refreshed version and we don't have to copy. So we do have like city ID, city name, state province ID, location, etc. And then we have maybe application state provinces. So state province ID, the state province, then the country ID, etc., etc. So within a lake house, you will always see something here. So when a lake house is created, 2 things are created. You get like a SQL analytics endpoint, and then the lake house for you to explore your files and folders. So this is where you can query your data. So if I select the SQL analytics endpoint, I can go ahead and now start querying my data. So like I can load my cities, I can combine those data points. Anyone who's worked with SQL queries, just by a show of hands. Any SQL developer, SQL is uniform across. So even if you're a software engineer, even if you're in whichever field in data, as long as you're dealing with data extraction and visualization, you're going to have to interact with SQL. So just to give a caveat, this session is not to teach you about SQL, it's just to show you what we can do within Fabric. So that is to say, if you're not good with SQL yet, you shouldn't worry, because yes, there are ways to learn, is it? And what I am trying to show, what the main objective with Fabric is, I don't even have to write those many SQL queries. Well, you can get a point to write them. And that's why everything is within Fabric. So I can analyze my data within Fabric. I can work with SQL databases, I can query, I can process. So it's a one-stop solution for everything. So if I wanted to write new queries, I just come here and say, I want to write a new SQL query, is it? But I can even open an SQL query in Notebook. For data engineers, I think this is not new to you. You may want, a notebook allows you to do a lot of things. You can work with different compute engines. You can, you can do a lot. So maybe they always say the best workload is the workload that gives you the fastest result. So instead of writing my query, I can just go ahead and do a visual query. So for example, I can name this, for example, I want, creating location data. That's the name of my query. And conventionally, I think it's best you just don't have white spaces. So a visual query enables me, in a way, I'm able to interact with my tables. Remember, I'm in SQL Analytics endpoint mode. So here I'm able to open my tables, and I have application, I have this other application table. And remember, I also uploaded the packages table. So what should I do here? I can just drag them to my canvas and start creating. So I can insert them to my canvas here, and I start transforming my data. So for example, in this case, I'll have there's this data preview section where, I have city ID, I have the city name, and then I have the state province ID, etc. Maybe I wanted to get more information about that state province, is it? So what would I do? I would load application cities to my canvas, and you can even limit that data preview. And then I can also insert the application state provinces data set or table to my canvas. What I want to do is I want to use Power Query in a smart way to even generate some SQL queries for how I can combine these two tables of mine. Again, the focus is not so much on querying your data. It's more to show you what we can do within Fabric, is it? So, for example, I would say I want to combine these queries of mine, and I want to merge them as new. Okay, so again, tools will be different, but concepts remain the same. If you've ever done an inner join, outer join, those sort of joins within SQL or even in R, they are all the same. So concepts are always the same. Tools is what will be different. And so in this case, maybe I want the left table to be the cities, and then the right table, I want it to be merged. So that is to say, if I have a city ID in this side as 1, and in the main table, 1 represents Nairobi, I want to be able to see this city this province exists within this city, which is named ABCD, right? So I want to combine my state provinces table to the cities table via what we call, can somebody give me a name for those keys? A foreign key, is it? So which will be the foreign key in this case? It will be the state province ID. So I just select like that. And in this other side, I also select like that. And it will even give me like the matches. So that's, again, not the main focus. And we want to do like a left outer join. So you have all these joins. You're joining all rows, left anti-join, right anti-join, etc. So I can join them, which is fine. I can even close this data preview. Oh, okay, wait. I can open the data preview, and then I will notice something. This side, it's a table, so I might need to expand it. But by expanding, I might need to use the original names as prefixes, etc. But I don't need all that information. So what do I do? When I've selected this query, I can decide I want to manage my columns. So I want to choose my columns from this table. So I deselect all, then I select maybe city ID, city name, then maybe what I want is the state name, is it? So state province name like that. But because it was held as prefixes, it's not coming as the right way. So I can just double edit it, click it, then I rename my column to be state province name. So I'm using camel case there. And suddenly I can go ahead and visualize my results. I can download it as an Excel file. I can even save it as a table. You can see that. So so that's my end result. So I've combined these two tables, I've even renamed the columns, and they're appearing here as though they would appear in Power Query, but it's slightly different because the steps are numbered separately. But you can imagine the code to create all that SQL table was this, but I've not had to write that code, did I? I've just connected some tables via the visual query. But that's to mean it's a low code or no code platform that enables you to even edit some of your queries, make them more performant, etc., etc. So in this case, I can just decide to enable load, and I want to save it. I can save it as a table, for example, or save it as a view, and then we'll use it to build our Power BI report. So that, in a sense, is how you ingest data into your lakehouse. And what has happened is we don't have that data in our workspace. I don't even have it. I don't own that data, but we virtualized it in our workspace, and enables us, if we were to create a machine learning model from that data, it's easy. We just take that table or that view, we load it onto our notebook, and then we build a model from there, which I think is what I want to show you as the last thing before we can go to a break.
Question.
Go for it.
Can you give the ERP?
Okay, not that I've experienced that. Is there an option for that?
No, I'm asking.
Yeah, no, I don't think. But I don't know what has happened. Let me just refresh the page. Let's see. Okay, no, I don't think so. I don't think it has that view. And one thing, I think you can always open the it looks like a Power Query, or it's a Power Query editor actually. So you can always open that, and it's a much more elaborate way to visualize your queries. So for anyone who's interacted with SQL and all that, you'll get to appreciate that you can have your things all in one space. And that was a visual query, but you can also just create a normal query. So you just come here. What is this? Model layout. Yeah, so that's more for data models. But the data models they are connected like this. So I think this will be covered more in depth in the session 2. So for your SQL query, like you can see, it's very much powered by AI. So it's just to speed up your workflow. You just type, it corrects, you use IntelliSense, everything is sped up in that sense. So you don't have to have your database on the side. Because that compute engine has been brought to Fabric, right? And here we are using the SQL or Spark SQL engine. You just bring your data, you bring compute to it. So it minimizes even the data stacks that you're talking about. Okay, so let's delete that for now. And I can get out of the SQL endpoint query mode. I just go to the lakehouse mode. And then, yeah, that way I can still see my files because I loaded that as a table. I can refresh, I think, and then it will just come. Then I'll work with it. All right. No, yeah, go for it.
You always have to save. So for any changes that you do in the visualized tables,
Yeah.
whatever you do, you always have to save. So that
You-
you get to the visuals.
You can enable autosave. You can enable autosave within the query. Yeah. So there's also something here. You remember I talked about endorsement. So endorsement is you're giving everyone or maybe your organization access to that data because that data is meeting all the standards requirement. You want maybe people to borrow from it or work with it. So that's how data access to the organization is also managed, because OneLake is a tenant solution. When you enable it, let's say for the organization, for us, for 400,000 people, they'll have access to that. The same lake house. But there's also recommended for use. There's also certified. So there are people within your organization, once set up, they can certify stuff. They can certify data. They can certify lake houses. And yeah, I think that is perfect. Now, there are many ways of getting data. You can get data through an event stream. You can get data via a data pipeline or new data data flow Gen 2. So this is for your pipelines. Gen 1 is slightly different from Gen 2. For Gen 2, you have to specify destination and it's a process, but those are different ways in which you can get data into your lakehouse. Now let's look at, for example, how the same lakehouse, we have access, we are collaborating. I'm a data analyst. I can create my Power BI from this data, etc. I can visualize. So for that, I would just come to the workspace here, and maybe I want to create a new item. And what I will do, if I wanted to create a report, I would just come and create a data report like that. Or maybe I want to create an ML model, or even I'm a data scientist. I want to create a notebook. How can I go about that? Let's say we have already loaded some data. Let's go to, so this is the data. Again, I don't have to work with it separately. I can just load it to that lake house and everyone has access. It's in the table and just makes work easy for all. So I will come and say, like, I want to upload the data. I will if it exists, I overwrite it. So this would be lab 3. If I'm loading the telecom data, I click upload. So I want to use, what is churn? Just anybody? Churn? Any synonym for churn is attrition, right? So maybe I am Safaricom and I want to check based on the calls these guys are making, these guys are likely to leave. These are very suspicious people. So if they are likely to leave Safaricom for Airtel, those are the guys I target with marketing. I give them offers because they're likely to leave. When I see their potentiality of leaving is to a certain threshold, I keep on adding them offers. And that's what even anyone who's used to Duolingo, those kind of models, Netflix, they will tell, Christopher has not watched in 20 minutes or I mean 20 days. The last time he watched, he used it for 10 hours only, and that was it. So you want to observe from someone's behavior based on the data about them. Are they likely to exit your platform or not? Because as you know, nowadays money is in services, is it? It's not in hardware or whatever. So are they likely to leave? So that becomes a pertinent question, which could be answered by who in the data sphere would answer such a question? Anyone from that table? If you want to answer such a question, who are you going to work with in the data professionals roles? A data scientist. And what model would be most suitable to predict such a thing? So I want to check how likely someone is to drop from my product so that I can make interventions in time. So I could be maybe running my models monthly, or I could be running them weekly, because if I don't arrest churn, I'm losing clients. I'm sure most of you who had DSTV subscriptions, no longer, is it? So you want to arrest churn immediately. How do you answer such a question? Using which model? I talked about 4 models, is it? There was classification, regression, clustering, and forecasting. So in this case, you want to classify them. You want to say, oh, based on probability, this group, how many churners? These are not churners, or likely based on a threshold. So you say, oh, if their probability of churning is 0.8, anyone above 0.8, we have to intervene now. Below 0.8, those ones can survive, So we upload this data to our workspace, then we load it as a table. You load it as a new table like that, then you start creating your model. Again, I'm just showing you the capabilities of Fabric. So I can say, I want to create a new notebook. So I just click new notebook, done. I'm creating a new notebook. And then, so notebooks are useful for both data engineers and data scientists. So within this notebook, I might need to add a lake house. So this notebook has been created within the Zindua lake house. That way I can access tables within it. So I can decide, okay, this is my model. I want to create a model. And again here, you will see a number of things. I can select my compute engine within a notebook, right? So I can say, okay, I can hover over a notebook and then I select my compute engine. I have Python, I have Scala, SQL, R, and even HTML, right? You can see. So Spark is the engine, then it supports different languages. I think it's by Apache Hadoop. Now, of course, I can set up my workspace, you can change, and this is my runtime. Now, there's something I said, you can configure your workspace settings, is it? So, for example, in this case, we are using Spark 3.5. We are using 1 to 10 nodes. So you can scale compute, and then you can also scale data independently. So that is an example of such. And compute, you can change depending on your requirements. You can enable high concurrency sessions. You can add data pipelines. You can run AutoML, that is automated ML pipelines. You can work in VS Code. For me, Copilot, I'm in the Fabric free trial, so it does not allow to access to Copilot. But if it did, again, that would just speed up my workflow. So the whole idea of Fabric is to weave and remove those data silos, remove all those requirements. I could show you a process for setting up an ADLS Gen 2 database, and it won't be pretty. It won't be this thing that we've just gone through here. Like, it's a lot of processes. So all that has been abstracted for you as a data professional. All you need to do is to focus on your work. So, for example, here, maybe, let me see, I want to import maybe general, all libraries that I'm going to work with before I can create my model. So let me just use this pre-made, pre-done code just to show you. I don't know why it's taking too much time. So all this, I just put it in my notebook. So I'll send you all this, but it doesn't matter. The core concept is, are you able to see how different data professionals are using Fabric to enable or to act on some of their problems? So in this case, it starts my session, so it spools the session. It takes a bit of time to, spool it, bring it up to speed, and then now suddenly I can be able to work with my data. So what I can do, I just take my data and I drag it to my workspace like that. And code is created. I now suddenly have access to my data. There's even engines that have been enabled here for data cleaning. So data scientists, what they do, they take data, they clean, they perform their model, they predict new cases, they monitor the model. So that's the whole end-to-end process very quickly. And okay, they also perform exploratory data analysis, but you can also do that here. So you can form charts, you visualize stuff very quick. One button click solution. Can also build your own, you suggest edits, etc. Can do new charts, and Data Wrangler enables you to quickly clean your data. So if you have duplicate rows, if you have missing columns, data with missing columns, all that, you're just cleaning them quickly here. Sort and filter, you describe your operations, you load your data. So all this is, your workflow is just being sped up like that. So we've loaded our data, maybe we convert it to pandas, then we do some EDA, like that. So where are we? Yeah. I can clear my outputs or hide them, so to speak. Then I can just create code. Maybe here I want to load my data, and notebooks also allow you to do what? So here's the data. I didn't want to focus so much on it, but fine, no harm. So the data here is, like I told you the case, if you're making calls, so this is your account, maybe your phone number, maybe this is to say, hey, Wale, walikuwa na number juzi, it's likely that they won't leave area code where they stay. Are they taking an international plan? Do they usually call people outside the country? Voicemail, do they have a plan? Is it prepaid or postpaid? What message, number of messages did they send in the last month? How many minutes did they talk in the last month? Total days, how many minutes did they talk in the evening, in the night, in the morning? How many calls did they make to customer care? Those could be pointers to why somebody is likely to churn or not, is it? So you have your data, you've loaded your data. The next thing to do as a data scientist would be, you want to just explore your data. So you do exploratory data analysis. Maybe you want to create a few plots here and there. And I maybe wanted to see what the proportion of those who churned and those who did not churn. Or then you realize that most people are actually not leaving your platform, almost like 800 of them, but those who are leaving are like 300. So you do your transformations, you do all your cleanings. So this is now the data cleaning part, which again, I'll just copy this code. Okay. Yeah. So you will create maybe some headings here. We call that data cleaning. Oops, I don't know what happened. Oh, fine. Takes a bit of time. And then you can, okay. The code here does not matter so much. It's about the process. So we are dropping columns that we don't need because you don't want to profile people based on their area, data discrimination, responsible AI, if you're into that. Actually think, as a career, if you're not so much interested in the technical side of things, you can pursue data responsible AI as a career. Because one of the biggest problems with AI is ethics. Like, I'm not going to shit on anyone's preferences here, but have you noticed some fonts, they don't take good pictures of Africans. And some actually are better off for that. So it so happens that it's because of the data they've been trained on. So yeah, so you see the whole ethics conversation about AI. So responsible AI, we have principles like you can't discriminate based on gender. In Kenya, if you look at loan data, Anne will tell us, but I'm not sure you've analyzed, but I've analyzed. I was about to say equity data, but yes, equity data. Female, like women, tend to repay their loans like at a higher propensity than the male counterparts, especially within the 27 to 40 age group. Now, when you're granting loans as a bank, I would rather give women, but you should not discriminate based on gender. So, responsible AI principles tell you there's certain features you can use and some you can't use, right? So we cleaned our data. Maybe we have 17 columns, so features, that is attributes of our clients or customers, and we have 1,000 examples of these customers. So what we want to do is we want to train a model that figures out, we don't know the weights, like we don't know the percentage of night calls that you have to make combined with evening calls and international plan and customer care calls that will make you leave Safaricom. But somehow from the model is able to learn that people who did this, they likely churned, and these who did this, they had this probability of churning, they didn't churn. So the model is able to learn the patterns, is it? And again, like I said, the focus is not so much on machine learning. As Zindua school, of course, it's a module, you learn all those mathematics behind machine learning and the likes, but the whole idea is to understand how you can actually leverage such a platform to create your models and efficiently even run and visualize. So maybe somebody just wants to know what are the characteristics of these channels, all that. You can analyze it even in Power BI. So all is here. If you wanted to combine that data to CRB data, you want to combine it to whichever data from a different platform, you just virtualize it, you bring it to your platform, and everything just happens within a single compute. So for example, now I have my clients, and then I split my model. I split the data. Like I said, we want to train the model on like 30% of the data. So we want to give it examples of 700 people. And then from the 700 people, we can test, okay, if we use those assumptions that the model has made about the 700 people, how right are we getting the 300 who are left? Is it making sense? Awesome. So I just want to run two models. Like I said again, these models, not so much to worry about. So we want to run a classification random forest model, and we want to run like not a regression, but we want to run a, what is it thing? We want to run a logistic regression model. And we just run that. Then when we want to now predict new cases, we run what we call experiments. And with the experiments, so random forest is giving me 92% accuracy. Like that is, I'm able to get 92% of the predictions right. So over 100 people, I said I got 92% of them right, in the sense that I got the prediction whether or not they were able to churn with my model 92% of the time. So of course, if my model is not performing well and I'm making my decision based on that, we are starting to talk about matters governance and ethical uses of ML or AI. But again, that's a different conversation altogether. So I didn't get to show you the run experiments platform, but the whole idea is now within this workspace, I can run different experiments. I can even schedule them. Every time they run, every time, I'm getting new data, I'm running new models, I'm getting new predictions, I'm getting new model weights to update my model on predicting whether or not somebody will default on their loan or not. And I think for now, let's pause there so that we can all take a breather before we can build. Now you can start building on your own. Make sense? All right. Anyone with a question? Was it too much to take in one session? Go for it.
Just going to describe you.
Yeah.
If you can just go back, I just want to, I think it's 15. Now you created the new shortcut wizard.
Okay.
Now you can connect it
With the other database. Yeah?
Yes, so we don't that.
No problem. So, all right. So let's go back to, I can go back to the fabric. Okay, this is the analytics endpoint. So lakehouse, sorry. So when we create a lakehouse, it comes with an SQL analytics endpoint, but we also get the lakehouse itself. So zitakuwa, there will be two small icons. One is just a house, but the other one is a house with some water below it. So that's the lakehouse. So you can open the lakehouse. Of course, you will be in lakehouse view, or you could be in SQL analytics endpoint view, right? Now, within the lakehouse view, you can, okay, it doesn't have to be in any view actually, but you can, within the lakehouse, you can either upload files, which you've seen me do twice now, right? That's easy. But you can also create a data pipeline, or you can create a data flow, or you can create a shortcut or an event stream. And I don't know if I touched on this, but okay, so Delta Lake is the format that we are using across Microsoft, across Fabric, sorry. So we are using the same format, which solves the issue of data disparity and data format issues. It allows for time travel. I would call it versioning. That is to say, I can go back, can revert to the previous version of the file if somebody has edited it. I can, restore version if I've made some changes. It enables us to have table-like properties, and it's the native storage for all Fabric artifacts. That is to say, Power BI specialists, machine learning, data engineers, they are just using all one format. So because of one format, everyone has access to the same data and everyone can work on the data. Now, the idea of shortcuts, I might not have gotten to it more elaborately like this, but my apologies. They enable you to create unified data experiences across domains. That is to say, for data engineers, they just access the same data. Across clouds, we saw different cloud providers, GCP, AWS, whichever, and across accounts. So we can even link to a different workspace. Oh, maybe Daniel has created a workspace somewhere. He just gives me access to the workspace, and then I virtualize the data, right? So they enable one copy. That is to say, you kind of work with the data as if it was in your workspace, but it's not. It enables pointers to other storage locations, which in this case could be all those different ones. Enables virtualization, and most importantly, shared security. Because once you bring it to OneLake, if it's supposed to be accessed by Zoe, Chris, Anne, and whoever, those are the only people who can access it within that workspace. So we don't give them access at Azure level, at GCP level. We just give them access at workspace fabric level. So data storage, data format, all those issues solved by shortcuts. And of course, I touched on this slightly, but the data lake house, which is a combination of a lake and a warehouse, is the center of gravity. That's where everything happens. You have the compute, which is Spark managed. So Spark has different engines. It's all about files. You're just adding files. So you have compute, you have data. So you're bringing compute to the data, or you're bringing data to the compute, whichever way you want to look at it, but allows you to scale them independently. Can support both structured and unstructured data. And it's slightly similar to area. Okay, that part I think we've really talked about well. And this is the difference between a data lake house and a data warehouse in the context of Fabric, because the primary tool within a data lake house is Spark, which is multi-language. You can have multi-table transactions in a warehouse, but you can't have it on this other side. The framework is folders, files, tables, but this other side is just database schemas. For anyone who's worked on, somebody asked me about ERDs, your schemas and tables only. All right, so I think that's fine. We've also set up and we've navigated the lake house. The loading formats, which is why I wanted to cover all this, you can directly upload files from your local storage, right? You can utilize Power Query with Dataflow Gen 2, which we've done, to import and transform the data. We didn't provide a visual representation, but that's something that we want to now focus in session 2. You can use data factory pipelines to copy data and coordinate processing tasks, like data orchestration and all those. And you can establish connections to external storage solutions with shortcuts. You can establish connections externally without copying that data. So that's what we want to do. So you come here and you create a shortcut. Sorry, am I moving? Or maybe it just went too fast because of the animations. But you come, copy data, new shortcut. Now with a shortcut, you can access data from Onyango's workspace or external cloud providers. So GCP, Azure, all those, right? But in this case, our data was stored in an ADLS Gen 2, Azure Data Lake Storage. It's a data lake within Azure. So we click it, then we establish a connection. So we create a new connection. So when you're creating a new connection, again, it tells you even where the data lake is located, because anyone who's done data privacy, within GDPR, we have those things to do with cross-border data transfer. So you have to have policies for that, etc. That's why everything has to be compliant. And the good thing with Microsoft and all these guys, they figured out those things. So whenever you're being audited, etc., you're sorted for your organization. You see, you will be a data strategist one day. You will be a CDO. You will be a data steward, data governance. Yes, it's good to be an analyst, but maybe what's your end goal? You can't be an analyst. You can be, but you're not looking to be an analyst all your life. You're looking maybe to move up the data ranks, right? And as a data strategist, as a data steward, you want to be able to define architectures for your organization. And in so doing, you have to take note of things like availability of those systems, their learning curves, but also importantly, compliance requirements. Now, we've said we are virtualizing data from a DLS Gen 2. We will create a connection. So this connection, we need to provide a URL, and then the authentication method can be shared access signature, SAS. That's why I provided a SAS token. Or it could be a workplace identity if it's within your workplace, because in this case for me, this is my organizational account, but this data is not from our organization. So I just need to provide the URL, and then I'll provide the connection credentials like that. So the URL is what I will provide, which I've included as part of the materials that will be shared with you. So this is data within, actually, if you want to learn Fabric, there's even conferences being held. Okay, I have not seen one for Kenya, but I just copy that URL because it was part of one of the conferences. Then I just paste that URL. Then I think because I had already provided the shared access signature before, it's just loading it from cache memory. But if you're prompted, you will just provide this token here. And the good thing, you see, we can't do anything to this data. It's read only, but we can bring it to our space, then we work on it. Sounds good? Up to there?
Yeah, I think that's right.
Oh, okay. All right. Anyone with a question? Okay. So, yeah, go for it.
Now, you see, I saw you are actually able to interact with some codes. Now, if you have to present the same results to the management, for example, now, would you be able to integrate the same thing?
This part and what you
because most of the people focus on the results.
Yes.
Instead of the coding.
That's now part of session 2. Yeah.
Okay. Just before you leave, Chris, there's an online question. Could you shed some light on FAIR principles?
Okay. Data governance principles, or let me just get that. I don't know. Yeah.
What this is asking, also in the lending sector,
Yeah.
where we are giving out loans to people.
Uh-huh.
You can see, she was saying, for instance, I'm currently working on a loan data set
Yeah.
with 1,000 clients, of which 50 claims are in arrears and 40 of them are already in arrears, making non-performing loans. The concept of responsible AI, if you are maybe creating a credit scoring model, what is fair? Like the way you are saying the gender, but it isn't responsible AI.
Can I add on to this point?
Yes, please.
Basically, the principles that he or she wants to incorporate into the credit scoring model, I'm thinking we are looking for principles in which you can input into your credit scoring model to prevent further defaults in the future. Okay, unfortunately, that would be a very hard thing to do because human nature is unpredictable. But I'm sure you can strategy in a more professional way.
Yeah, I think I have an answer somewhere. It's a document I've worked on at some point. So allow me to, before the end of the second session, as we conclude, I'll give you an answer to that. Yeah. So that I just give you a detailed breakdown of those that you need to consider. Of course, not all. And some some principles. The problem is some are diametrically opposed to your objective. So what if their education level, okay, maybe that's not discriminatory, but we are trying to avoid also discrimination. But what if that thing which is discriminatory in a sense is what separates the defaulters and the non-defaulters? So there's a principle that talks about professional courage, and I'll elaborate more on it once I get like the context on how it relates. I mean, it really relates to credit scoring. Yeah, but we are seeing a lot of people are moving from more traditional statistical methods of prediction to more machine learning based. But the problem with the ML based approach is the black box thing. Like you don't know the weights it's assigning to different features to give you that result. Or even if you know, okay, some models you can know, some you can't. But the ones that you can't are the ones that usually perform even the best. So it's a dilemma. And so there are ways to mitigate that through, you transform your data, you transform some things. Again, I think it would be best if I gave you an example model, and I also give you some of the considerations we've made when we are working with such kind of dicey scenarios. Yeah. All right. So I think we can take a break, and we come back after 30 minutes. It's not sure.
Right. Thanks for that, Chris. I hope I'm audible enough. At any point, if I'm not, just scream. Cool. So, yeah, a lot of demo has been done already with regards to how we're moving from a workspace to a lake house to an SQL endpoint, and then be able to see at least that whole layout. So, ideally, this is what we're supposed to do for this session. Move from creating a workspace, we already understand it's just a container. And we're organizing our work. We're deciding that for this project we're working on, we just need a workspace that is related to us and that project. And then we're controlling users, who gets to see what data we put there. That's the whole charade. Then we're going to a lake house. Of course, that's built on OneLake. We've already gone through the advantages of that. Now, from a lake house, those are the three sort of hats we're going to wear today. We can utilize a notebook. We've already seen that when we went through how we built that model. We can utilize a SQL endpoint, just run our queries, and we can now build a semantic model to go to Power BI. So what we've not seen is we've not seen any visualization so far. And that's the gap. Now, two ways to get to that. One is we can visualize this in a notebook. We can go to our notebook, use pandas, whatever library that we want to do our EDA, visualize a few things. The other route we can take is from the result of a query, we can turn that to a visualization, turn it to a report. Case in point, if let's say we have some transactional data on sales and we get a request, how is region ABC performing? We run a query, group this by this region, give us the total sales. We get a result, we convert that to a visualization. That we can share out, we can do whatever we want. That's route B. And then finally, we can build a semantic model from the various tables, various data sources we have, and then just build an entire dashboard. So that is the layer that we'll cover. This first bit, all good. Correct? So we'll still be working within that same workspace that we had, and with a very interesting name. But I will not bash him for creativity. So first thing we'll do is upload some files, right? So for this session, we'll be working with, and normally it's good practice when you're working, just from the whole sense of a workspace to giving us that opportunity to sort of have our own environment. When you're uploading files, it's good to utilize the subfolders. Now, what gives you another layer of just organization? So we'll start with having a nice subfolder here, and we can call it sales data. And then we'll create that. And then from this, now we will upload a file. So allow me to get one file here, which is this. Okay, that should be good. And then, yeah, voila. So a few things we can do after uploading a file. We have the three dots here, and we can utilize the properties section. Lets you know a few important things here. So one is the name of your file, of course, but you have some paths there that are quite important. So you have a URL, a relative path, and another path there, ABFS. Now, why that's important is if you're reading a file to a notebook, you're referencing this. And I'm sure you saw that in the first bit, right? So just an overview, when you last modified it, so you can keep track of all that. So that's the properties section. Of course, you can have a preview of the data. So it's a CSV file. So let's get to see what's there. Well, not pretty at all. So what we'll do instead is we will just open it via Excel, just to see it a bit before we interact with it on the other end. So it's just typical sales data containing transactional data on sales being made. And what I want us to understand the data set at this point is so that you can know what we are visualizing at that time. So you can see we're tracking some order, just tracking orders. And you can see we have status, so we can maybe decide to group orders by some status. We can also decide to, what else is interesting here? Yes, the deal size, we have a country. So we're just tracking orders from various countries. We have a status there, and we're just capturing as much data as possible. So we'll query this data a bit and see how we can come up with visualizations from this. So back to Fabric here. Now, at this point, we are good. Our data is downloaded. It's uploaded, not downloaded. Two ways we can, and we already understood, we'll start with three ways rather. We'll start with the first one, a SQL analytics endpoint. So I'll just come here, and you'll notice down here you have a new section, a query section. Now, two folders are already created for us, my queries and shared queries. So if you're working within a team, you definitely find yourself with shared queries that you're working with. Everyone can contribute to that. You can also just have your queries there. Now, by default, you also realize that we have, this is now the model that we will create later. But let's park that for the minute. So let's come open a new SQL query. Just give it some time. That's one way to go about it. You can also use this section up here, just gets us to this point. So most of us have worked with SQL. So that should be good. Let's come here. But we'll just do some very simple queries. Now, for those who haven't interacted with SQL, what we'll be doing is just getting the sum of sales there, getting the total sales per year, and then we'll do a grouping by the deal size. So those are the queries we'll write. So if we come to our Fabric here, let's say we want to, first, what's the name of our, okay, I'm rushing. Here under schemas, very important section. You can see we have DBO, information, query insights, and some systems. So if we open the DBO here, you can see we have folders for tables, views, functions, and stored procedures. Now, tables, we already understand what tables are. Views, you guys, I mean, SQL, I had people out like, what are views? You said it. Exactly. Temporary tables, right? So if, let's say you have, in relational databases, when you talk about relational databases, we have data as units. So we have sales, customers, and then we are finding ways of connecting these tables using the foreign keys. Now, a view is, let's say you have a common question. Case in point, maybe there is usually every morning there's someone who just wants to know how sales are doing per region. So you do a join, and that result, you just save it as a view. It's a temporary table that you don't have to keep writing that all the time. Next is a function. Functions. It's not an SQL class, no pressure. Stored procedures. Those long queries that you don't want to keep writing, store them there. Right? So it's nothing new. All this is in if you're working within SQL, relational databases, Workbench, all these things are there. So they've also been brought on board here. So our tables, ideally, should be here, but we've not converted our file to a table yet. Still a file. So once we load it as a table, we should be able to see it here. Once we create our views, we should be able to see them here, and so on and so forth. Our functions, stored procedures, all that. So first thing we just go to our file. Where is our file? And just go back to the lakehouse. Also, very important button, refresh. Every time you're pulling in data, just refresh. Sometimes you're wondering, wait, I loaded a file, I can't see it. Just refresh, should be good. So let's give it a minute. Okay, so this sample of mine does not want to appear here for whatever reason. So we just do it from here. So we just load it as a table, and then you can see if it's a CSV file, already detects that the separator is a comma. CSV, comma separated values. If it was a TSV, there will be a tab, so on and so forth. So we just load that. That name is quite all right. Again, I'm not bashing anyone for creativity. So now we should be able to see our table. Let's just load this. Again, refresh it. Yeah, so here it is. That's successful. That looks good. Okay, so we can go back to our queries. So also, from a table here, you can open a new query just from the table itself. So next to these three dots here, just a minute. Come on. Okay. So it's deciding to embarrass us. No worries. But from here, it should do it quite well. So we'll just refresh again. So here it is. Here's our table. So from here, we can open a SQL query. So just get your table of interest, new query. Again, from up here, we saw we could do it. So various ways to just doing the same thing. So we said we'll just start with very simple query, which is, let us get the column is sales. So say we want to get the total sales. So we say we want the sum of sales. Can give it an alias, let's call it total sales. And then it's the name of our table. Sales data sample. Okay. Sales, there we go. So let's run our query there. Something is off. Just resize this a bit. I don't believe it's case sensitive, but who knows? There we go. So we have our results there. Now, in the case where you're building a report, and let's say we want this to be one of the visualizations there, how would we visualize such a metric? What could we use? In Power BI, maybe just a card, right? Simple card. So how we go about it is just make sure you select the query, and then down here, just come and visualize results. So it's going to give us a summary of our SQL statement there, and then we just continue. So this now opens Power BI service, still within Fabric here, and we can convert it to a visualization. Let's give it a minute to load. So we all know this interface if we've been on Power BI, right? And it's quite simple. So you can see our queries here with the result that we had before. So we just drag our card. So we want a card, and then we can say our total sales. Just drag it there, give it a minute, and that's our result. So now we can do our formatting. If you want to give it a title, all that. Again, I feel like I want to linger here, but it's not a Power BI class. So one way you can go about it. Down here you can see a button of Save as Report. So you can click on that, save it, and very important, destination workspace. Now you see the importance of workspaces. Everything you're doing will be within that. Now from your workspace, you can share it out. So if you have how do we share reports on Power BI? We just publish them on Power BI service. We can embed them on PowerPoints, right, as a live link, all those ways, because we already have the report. And once we do this, let's save it. If we go back to our workspace, this, and then see, have our notebook, give it a refresh. Okay, let's add a few. It shall appear here. Let's go back and do one more. We had a grouping by what? By the deal size. All right. So let's do this. Let's select the deal size. And then we sum the sales again. From sales data sample, and then we'll just definitely group by our deal size. So let's see. Okay, looking good. So we can see the contribution by every deal size to our total sales. So creating a visualization again, just make sure you select your query, come here, visualize results, back to Power BI. And then what can we use here? What visualization could we use in this scenario? So it disappeared again. That's what I saw it load. All right. Good thing we can just do it again. Let's go. Interesting. Nimesema pia ni one term. Let us refresh again. See what's up. Okay. So let's do that one more time. Select deal size, and then sum our sales. Sales data sample. Group by sales X. Okay. Very interesting.
I think what happens in
What happens in
with the sample data.
this one, if you go back to the table, I don't know if it's
I thought it goes somewhere. Nika inapotea.
Yeah.
Sorry.
So are we about to blame the tools?
No? Maybe you're referencing the wrong. Maybe we can confirm the name
Of the what?
of our data, yes.
It's okay. So see, we have a result.
So, yeah.
If we have this, then definitely we should have a visualization. So I don't know, they're being recorded, so I don't want to bash them just yet. So since we have, I don't know what's going on, honestly, but it should be able to visualize that. And we can try another one. Final one was sales by year. Okay, so let's see. So we want, should I have shared this two screens? What columns do you need? Year ID. Okay. Year ID, and then the sum of sales. That's total sales. From the sample data. And then year ID. Okay. So normally when you don't highlight your result, that is the error I was expecting. So this is a bit strange because, but anyway, let's see. One more time. Fantastic. So probably didn't like our previous query. So again, same concept. Now here, what? How can we visualize this? Here ID, total sales, budget maybe. Let's see. Yeah, let's cross our fingers. Okay. So, okay, let me just do this. Ah, okay. All right. So we're getting somewhere. Well, not the best data to visualize like this. So let's see what you can do. Not too bad. Okay. We will not save this report. Sorry. Yeah. So the year has it's 0, 0.5, and 1. So I'm expecting you to treat it as categorical. But that's besides the point. I still can't get over the fact that we were not able to just one more time. Okay. So it clearly has a problem with our brain for some reason. Anyway, so that is route 1. All good? So route 2 is using the notebook. So we've already done that. So how do we open a notebook? So we have a notebook 1 here, so we won't touch this. We can open a new one. So default, we can go back to our lake house, open notebook, and then a new notebook, like that. Did I just see the Power BI logo? Yeah? Yeah, I saw it too. Cool. So within your notebook, you can use PySpark, pandas, whatever it is that you want to go about it. But important to note is if you're working with big data, of course, pandas is not the route. PySpark is you utilize this package. So we can do our first thing is, of course, importing the data. Hence those file paths that I was showing you guys earlier. So you can go back to our lakehouse here, come back to our sales data, go to properties, and then we will use, just copy the path, come back to our notebook 2, and the first thing I do is I just can import pandas, SPD, run that, and then just I'll read this file. So that is the path. Just assign it to a variable there. Let's call it data. Let's see. Okay. Interesting. Okay. I don't have time to debug that. So what we'll do instead is come back to Chris's and then, oh, he already visualized. Ah, okay. So this is exactly what I'm about to show you guys. It's nothing new. So this is the other way you can visualize data. So I'm sure he imported the importations right here, used Spark. That is the data set he was using, and then converted it to pandas down here, and then now he was able to just go and visualize. Now that's a value count of the distribution of customers per churn, not churn, etc. This is route 2 of how you can visualize. So route 3 now is the semantic model. Now this is where most of our time will be at. Now, let's first discuss what a semantic model is. So I'll just go back to the slides for a minute. Right here. And I'm saying from the beginning. Just a minute. Right. So most of the time when you're building dashboards, you find yourself working with relational data. And as we discussed, relational data is data that has been stored as units. These units are representing business entities. So case in point, you can have a table for our customers, another table for our staff, another one recording order items, and then we're finding ways of just tying them all together using foreign keys, etc. So a semantic model, you can think of it as you packaging your data to answer that question that you want it to answer. Now, if you're building a sales dashboard that maybe you want to look at performance of, maybe you have salespeople, then you know at the back of your mind, I need to find a way of tying my sales to the salespeople who are selling. Now, be it using foreign keys, all that. So a semantic model is just that structure that will contain all the tables that you need for your dashboard, plus the measures. When we talk about measures, we mean those metrics that the KPIs that are important to you, etc. And a semantic model will always be made up of 2 tables, facts tables and dimension tables. Facts tables will store those measures. These will grow over time. So if you have transactional data, it's here. Dimension tables are storing your facts, like all your stuff, all your customers, just a table keeping track of that. And then from that table, you're creating relationships to your facts tables. So let's say someone makes a sale, then that order has a field that it is tracking, hey, I have been sold by salesperson ID XYZ. Your dimension table there has all the IDs and all the names of the salespeople. So you're able to see the sales per salesperson. Now, this is usually the backbone of any Power BI report. No, you can't build a dashboard without this. Otherwise, it becomes static. It doesn't make sense. You can't use filters. You cannot. It's not painting the organization's picture. You can visualize facts, but you cannot tie them to concepts within your business. So a semantic model is that whole structure of you taking the tables that make sense to you and then finding ways of building relationships to each other. And so it will have our tables. Of course, this will be a combination of the two relationships. This is where we will at least spend a bit of time on measures. Here we write a bit of DAX. So DAX, another language again, right? So not too difficult. Okay. So yeah, we write a bit of DAX there to calculate some aggregations. So total sales, sales per region, sales per what, some small code. You can create some calculated columns, etc. And then, of course, metadata is always data about your data. So versions. So this is what we want to build. This shouldn't be strange, because if you worked with Power BI, you started with creating a workspace, and then you got your data, and then you built this. Within your desktop, build your report, published it. And in every published Power BI report, you're able to see the dashboard, and then just below it, you can see your model. That's exactly what we're doing here. Now, it's Fabric. When we spoke about earlier, when Chris was talking about the workloads, right? The data factory, you went to the ML, Power BI is also a workload. And this is how it's supported on Fabric. So it turns out, when you're building a dashboard, do you use Power BI Service or Power BI Desktop? Which do you guys prefer? Desktop, right? Then you should be worried, now that you're on Fabric, how will things get done? Actually, nothing to worry about. So the workspace you create is still accessible using Power BI. So once you create a semantic model on Fabric, you can go back to a Power BI desktop, access the workspace, and we get our model. Becomes easy peasy, we publish, and we're all good. So that endpoint is very well catered for. Alternatively, if you're doing quick reports, just those requests that do not annoy you on a Monday morning, you just do them on Power BI Service, quick, fast, publish, send them out. So let's get to this. So we'll be working with a couple of data sets. So let me find my way to that tab that has what you need. I'm sure it's this. All right. Here we are. So I'll create another subfolder, and then you can call it I'm very sure I had opened this dialog box before. And then, all right. Dashboard subfolder, or dashboard demo. That's how you write both. Is anyone coding along? You are? Okay. You've seen the data sets that have been shared by email? Okay. So if I'm too fast, just let me know. If I'm too fast, just let me know. So here we upload a few files. So I'll talk about those files after as they're uploading rather. So here they are. Yeah, fair enough. Just give it a minute. So there's a common data set that's also it's on Kaggle. It's a good one to practice SQL queries. It's called the bike sales data set. I don't know if you've seen it before. Bike sales. So what it does is, and as this uploads, oh, all right, there you go. Let's just come here. Oh, I've remembered. Actually, I also have it on my slides. So fair enough. So this is the data set that we'll be working with. Just an overview so that you can, once you're making those relationships, it makes sense. So it's just a retail business selling bicycles. Now they have, given it's relational, data is in various tables as follows. We'll have an order items table that will be storing all the transactions, all the orders that are being made, they'll be stored there. You'll have, and you can see here, fact dimension table I mentioned earlier. A fact table will have, this will grow, it will scale because it's transactional. But a dimension table will be storing the facts of our business. Contradictory, right? Fact table, but this one has facts. If it's the product, it's only the product you're selling. And in a product table, in a dimension table, an entry will only appear once. This is important because it will influence the types of relationships we make. And given we've all said Power BI desktop, relationships are not a strange concept. The one to many, many to one to one, right? And what we mean is, if in this table here we are just storing a column with our products and a unique identifier column, right? Maybe a product's ID, then other items will definitely have a repetition of products because someone can buy more than one product. And so the relationship between the two will be a one to many. So all the dimension tables, they're always on the one side. The fact tables on the many side, because you can have repetitions of the items that we're storing in our dimension table. So every dimension, and you can see, still the whole lot is just dimension tables because we are tracking all our orders here. So we have to find a way of figuring out this order that's being made here, what product is it? What's that? From the customers, we can know which customer has made that order, from which store, sold by which staff, what brand was it, and what category of product that was. So that's what we're trying to build. That is, in essence, the model. So it will look something like this, whereby now this is just those tables expanded with, what do we call these names down here? The names, this customer ID, first name, last name. Honestly, I've just forgotten. I want you guys to give me like a booth. But anyway, so. Sorry? Yeah, the attributes. Correct. Yeah, so thank you for that. So we have our attributes. Of course, we have our, in Asterisk there, we have our primary keys, and then these notations here are just notating those relationships that we are talking about. So is it the ones to many, and of course, a whole other conversation. But this is what we are building. You see? Now, this is the model that we're trying to come up with. So, not too complex, again. So we'll just do it quick, fast. But at this point, I just want us to understand like that data set so that when we build the dashboard, it makes a bit of sense, right? So, at least we know we are selling bikes. We have orders. We have customers who are buying bikes. So that's a good sign. And then we have some staffs. And then we are keeping track of our products somewhere there. And our products seem to have different categories. So we have a grouping of our products. We are keeping track of our stocks here, the stocks in the stores. And then also our products are from various brands. So we can look at maybe the brand, what brand are people buying aside from just the product. We can just be even more granular. And then other items here is what is keeping track of all our orders. So all good. And we have a discount. Fair enough. So we can go to Fabric now. All right, so the files were uploaded.
I think when in a stream, so it's showing the other window. I don't know how. It's sharing something wrong. But it's not okay. Yeah. So.
Let's give it a refresh. So step one will be converting our files to tables. Come here. I'm about to blame the tool, but I just don't want to. I promise I don't want to. But we have uploaded files, and then they're not there. But yeah, one more time. Be patient. Fantastic. So I just want them to appear here. very easily, but they're just insisting on the other place. So it's okay. So we'll do a very manual process here of just loading them as tables. Oh my goodness. Okay. Dashboard demo. So here, just load to tables. Yeah, we'll just retain the names, no problem. I promise I've tried to find a quicker way of uploading many files at the same time. Probably a good suggestion to. They have a, yeah, this guy's document. Yeah, they have a nice community, so you can go and say, hey, how do we upload all the files at the same time? Haven't figured out that part yet. Meaning that we have to do this for all the tables. And they're just 10, and shouldn't be too bad. I thought we'd have a countdown as I upload them, but fair enough. No need for one. I feel like there's one that I missed. Customers, right? Yeah. Nice. Nice. Okay. So here we are. We have the brands, categories, customers, other items. Let me just minimize this. Yeah, seem to all be here. Seem to all be here. So once they're here, I believe we've gone through everything up here, but from new semantic model. So that's where we go. So new semantic model. We give it a name. Bikes. And then that's our workspace. So let's come here, select all our tables. Of course, not all. Really? Okay. Fair enough. Wait a minute. We're not in WP. Are we in WP or LH? It's your workspace? WP. Okay. Let's give it some time. What is going on? Okay, so brands, categories, customers. Other items. the data that you had, is it heavy? The data you had previously? I'm wondering why it's okay. It's behaving now. So 1, 2, 3, 4, 5. I don't think we've left out any table. You cannot give it a name. Okay. Right. So again, quite familiar. So we've all seen this interface before. If we build a dashboard on Power BI, so let me just minimize this a bit. So all our tables are here. Now we need to build our relationships. Compute session disconnected. Okay, it's the notebook. So building the relationships. Few ways. What's one way? How do we build relationships in tables in Power BI? You have and I bet you sound better than myself. Yeah, you can drag and just like that. Now that might take us forever. The other way is just manage relationships, and then you can just come in, just manually input your relationships right here. So we'll use this instead. So we're referencing the model down here. Let us see. So orders and customers, start with that. What are the orders? So my fears are coming to life. Let's see why it's doing that. 1, 2, 3, 4, 5, 6, 7, 8. I might just confirm something real quick. Just want to confirm whether that orders table is still there. I seem to have lost one. Okay. No problem. We'll just work without that. Go back to our model. Oh, so you're noticing that everything we're creating is just being appended to the left section right here. So from our notebooks that we haven't closed yet, everything is just to the left. So our model is right there as well. So we'll come to manage relationships, new relationship. There we go. So orders is not there. So order items and products. Products. And then what columns do you need for this? This is a foreign key, and the primary key is right here. And of course, Power BI automatically detects the relationships. I don't know, has it ever gotten it wrong on your end? Never. Fair enough. So that is it. So a few more to go. Just bear with me. Yeah, then will be products and brands. All right. So product was a dimension table. So I'm guessing brand ID and brand ID. All good. Many to one. So in this case, the brand ID is a dimensions table, given we have multiple products per brand. And then products and categories. Oh, good. It's doing a lot of work for us. Products and stores. That does not seem to exist. We don't have a store ID in the products. Okay. We didn't have orders, so we have stuffs and stuffs, stuffs and stores. All right, let's see, stuffs and stores. I'm guessing this is tracking the employees working in a particular store. Okay. Looking good. So just close that, and you can see our relationships are already here. Let's try and drag everything right here. So there it is. Now, that is just the relationships part. What was the other bit that was making up our semantic model? Measures, right? The metrics to visualize. So, right here. But at this point, once we have our bikes mod, we have these relationships as so, we can do this. Let's go to Power BI desktop. Let's just open it. They want us to see that we can access this model from Power BI desktop. Just start with a blank report. Okay. So we're going to get data, and then Power BI semantic models, as it should ask us for a workspace. So what workspace does it get the model from? So give it a minute. So there we go. It was the bikes model, right? So bikes. Just looking for the connect button, guys. But we found it. So give it a minute. So let's look at our data section here. Let's expand it. So there we go. And of course, the modeling view right here. Let's minimize. At least these things look familiar to us. Right? Oh, good. So from here we can go ahead and start building our reports and publishing them. So can create a measure table. So let's come here to the modeling tab. Let's create a new table. Seriously. Today's a day, yeah? Cool. Hope you guys are having fun in my misery here. That's the only fun we are getting today for some reason. Because we also seem to have lost the new table option here. Ha. Cool. So just 5 seconds. I should be good. Let's give 5 seconds to internalize all this. Cool. Should we head back to our Power? Anyway, you should be able to create. I'm also surprised as much as well that you should be able to create a new table from there and just do everything. Let's try a visual. Let's try a card. Let's know how many unique brands we have, right? You need to write DAX for unique brand. We could, but we could also just drag it here and it's going to give us a unique count. At least something. So we can have the unique, we have 9 unique brands there. And what else can we see? Let's see what one measure that we can create that makes sense. What do you guys need to know about this data? Some measures of interest? Profits. How do we get to profits? It's usually the first question. Start with sales, right? So sales, we'll look at order items multiplied by the list price minus the discount. Remember we had a discount. So I'm about to say something that is going to sound like a joke, but you remember we do not have the orders table. That's why I just had the answer and I had to laugh. But you know what? You could actually get together. Let's redo that all together. But now you guys should be guiding me through it, right? So if we wanted to add a table to our model, how do you think we go about it?
To expand.
To expand? This. Okay, we actually don't need to be here. We need to be in the lake house, right? If we had to start here. Right here in the lake house. So we are missing an order items. Order items or orders? What don't we have? Let's confirm. Orders. All right. Yeah, we are really attentive for sure. I'm the one who's not attentive. Fair enough. Could it be? So one idea. So she's saying we start by confirming it's actually in the tables, right? Because before it gets to the model, we start from a file to a table, then to the model. So let's see. Order items, it's here.
No.
Clearly, I'm not attentive. Okay, fair enough. So dashboard demo here, orders. So it's here. So let's see. Let's convert it to a new table. Yeah, I think she needs a T-shirt. I don't know if you guys can hear me. Not my T-shirt. I still get my T-shirt. Fair enough. So tables, we have T-shirts, Chris, just to confirm. I feel like, okay, great, fantastic. For me. Okay. So it's here now. So we now take it to the model. Now, our model is here, so we don't need to create a new semantic model. So from here, how can we add a new table? Power BI people. That was too fast, man. Fair enough. Too fast, but it's good, right? So it opens up our where we have our tables on Fabric. So just go to we open our tables, just scroll down, orders. There we go. There. And then yeah, don't do what it wants to do. Let's close this. Did we edit existing? Just a minute.
I think you unfixed the other tables.
Yeah, but it shouldn't even be a problem because we are on. Yeah, that's another bug. We are already on bikes model. When we edit that, it doesn't need us to re-add, but it definitely wants us to re-add. But that shouldn't be the flow. When you're editing on Power BI desktop, your model is still there, just appending tables. And the BI didn't want us to add tables, but we'll give it another shot. So at least here we can add a new table. That's good news. But anyway, let's now catch up to our whole semantic model again. It's going to be quite a task, but no worries. There we go. This time, making sure we don't leave out any table. So customers, order items, products. What's happening to this now?
Please allow me to do that.
Yes, please.
I'm curious.
Yes.
I want to know if you are creating a new table, is it possible to create a new table from the previous table that I had that have the order the graph of the other details? So that at least if you are interested to, let's say you want to answer a question, you can be able to pick from
That table.
the previous table that you had here.
Yes. So you can call them calculated tables from calculated. Ideally, what you're referencing is just a measure table, like a grouping of every metric that you want to swap. That is exactly what we want to do. So it is very possible. Yes. Hence why I was so pissed that we weren't able to create a table there, because then we'll have measures everywhere.
The thing is,
Yes.
at least you need to get the idea of how you
Yes.
can be able to maneuver.
We should be able to do that here. Yeah. So everything is there. 1, 2, 3, 4, 5, 6, 7, 8. Oh yes. So orders is already there. So should be 9 now. Or then it's going to take away the orders and then we have to redo it again. I feel like it's telling us just be prepared for anything. We should just look for the orders. Is the orders there? Oh yeah. Okay. Trying to run away from us, but right. So next, relationships. So we are redoing the whole thing again. I like the sound of that.
Are you able to now, if you want to answer some questions about the orders, you have the customers, order numbers, product, the staff, right?
Yeah.
Now, are you able to do this thing from this table, that over here that you have?
From here,
This place?
no, we have to finish with the model, go to the file view, and then build the report view from the report view.
Sorry.
Yeah. It's all right. Okay. I mean, there's someone who's more tired than you over there. Don't point fingers just yet. But that was a bit loud, I mean. So orders, customers. I hope my not so good jokes are just helping. Orders and customers. See. So customer ID, that looks good. So that's a many to one to many from the customer's end. That's done. I'm beginning to think maybe dragging and dropping is not so bad after all. But order items and orders, that's good. Order items to products. Yeah. So this was our column of interest, list price, to get the metric you were suggesting. Products and brands. Sounds like we're having a good time here. Yeah? Can be worse than that. Can be worse than that. Products and stores. Okay, so this is not taken from the beginning. No problem. Orders and stuff. Okay, good. All right, seems to be good. Okay, looking good. Let's close this and reopen it again. Hopefully it comes back with a table. And that looks good. So now we can go to create new report. That is the place to build our reports, and now we should be able to do so quite well. And at the same time, this is our last item for at least my part. So just bear with me. Cool. Let's see whether the desktop also. So let's get data from our semantic model. Thanks. I feel like I just trust that is a button. Let's confirm. Okay, and then the moment of truth. All right. Say less. So here can come, so a couple of tabs here. So if you want to check out our data model, just right there, opens a new tab, of course. So we can visualize our model from that tab. We can, and this is the part to build the reports. Now, saving that will come definitely later. So now let's do this. Do it. Just create a new table. And that is it's the only restriction we have on Power BI service, but fair enough. And just create measures within an existing table. No worries. So come here. Serious. All right. Here we go. Call it measure table. And then I'll just have a placeholder, just like that. I'm just creating an empty table that we can populate. So now it's here, measure table. So some metrics can start with yours. And it's right here. If we go to our slides. So here we have some DAX of calculating the total sales. So what we're doing is just looping through every row in the order items table. And then we're getting the list price, multiplying by 1 minus the discount. So that times the quantity bought. So the list price minus the discount times the quantity. So every order, remember the order items is storing every single order made. So you make an order, it's a row there. That's why we are summexing or looping through every row there, getting the list price in each row, subtract the discount, multiply by the quantity ordered. Make sense? I feel like you're looking at me, but I'm trying to direct us there. But that's what you're doing. Fair enough? Okay. So I'll just write that DAX over here. So in the measure table here, just come, create a new measure, call it total sales. So just sum X, and our table of interest is the order items table, that. And then we get, from the order items, we get this list price here. So trying to find use for this desktop of ours that is, where is it? This. Why I want to do this is I want us to have a table view of this. This. So this list price here, we take away the discount, we multiply by the quantity bought. There we are. Subtract from 1 minus the discount, like that, and then we're multiplying this asterisk right here by the quantity bought. There we go. Fantastic. Another measure. Total orders. Now, the distinct count, we don't need to write that. When you drag any field into a card, or just gives you the option of counting distinct. So no need for two. The third one here we'll calculate will be the average order value. So per order, what is the average value per order? It's an important metric. Maybe if we want to optimize, maybe our orders come with some expenses like transport, and we just want to make sure that our orders are getting passed. So we're just dividing total sales by total orders. Total sales, of course, is the metric that we've made up here, which means we also have to create total orders, which is okay. So here the next measure will be total orders. So we are calculating distinct, so distinct count of order items. The primary key there is order ID. There we go. That's good. And then now we can have our average order value. And this will just be, we divide the two metrics. So total sales made divided by total orders that contributed to those sales. To that point, we're good. Okay. What am I missing? Oh, this is a comma, it's not. So the Excel in me is showing up at the worst of times. Perfect. Let's see, what else do we need? Okay, so the rest we do not need. We'll utilize now our relationships. So all good up to that point. So we're done with here, tables. This is it. So could just go ahead and close our tab. Similarly, can close our tab. So we have our relationships. We have a few of our measures there. So we can go ahead and build our dashboard. So just come to File, and then we create a new report. Fantastic. So it's the first thing we can have on our dashboard. Title. Oh, we don't need that. I agree. We do not need titles. So we can have our three very important KPIs up there. So we use cards quite simply. So I just drag the card. So we start with total sales, right? Can at least make it a bit better. So we can maybe kill that and give it a shadow, just because we are fancy like that, or maybe not. But let's have a title up there. Total sales, and then I'll just duplicate this. Okay, there you go. So instead of total sales, the other KPI could be the total orders, and of course I can just amend the title there. Oh, you can also center them. I don't know why they are to the left. Let's just center that, and then someone who said center div. That's a good joke, actually. It's a very good joke. And then finally, average order value. Fantastic. Okay. Let's see what else you can do. You can look at sales by product category. What visualization could we use for that? When considerations, okay, not a visualization class, but when you want to build a visualization that has groupings, what are you considering? Because here we want to look at the contribution of sales by the various product categories that we have. So what should we be concerned about there? Sorry? But I'm not talking about the visualization just yet. Before we get to that point, what is it? What is telling you I don't want to use a pie chart? I want to use a bar chart. There you go, right? We cannot have 13 or 25 unique categories in a pie chart. Right? We can if they're not contributing much, and maybe we just want to focus on the three. But anyway, I'm just making up for the fact that this tool is embarrassing me for. at least you're together. So we might want to know the unique categories. How many are they? Where are they? They're here. So instead of writing a lot of code, you can just drag it there, and then you can just have 7. So 7, not too bad for a pie chart. Right? You can try 2 many. I think I agree, but I'm making all that. So I'll have on my legend will be the category names, and then I'll just use my total sales measure from earlier. Fantastic. All right, let's see what's up. We're looking with categories. So anytime this happens, confirm you have a relationship between the two tables. Right? So learning points, not embarrassing me. So let's go back to our model. Here, we are looking at categories and total sales. Total sales was a product of order items. So order items and categories, let's see. Order items and categories are here. So in the order items, we have a category, but we have a product ID, which goes to product. So what we are missing is this. It is category ID, I believe, to this category ID. It's there. Okay, it's already there. Interesting. Okay, let's see. Into details, but what other categorization was there? Let's look at brand. So giving us a bit of problem. Let's just see. List price and products. Okay. Just bear with me. See if we can look at the orders here. We have an order date. Yeah, just a minute. And then on our measures. Okay. Now that is strange because it's accepting that, but it doesn't want to accept something else. Let's give it one more shot. So this is just a trend of sales orders over time. Right? Not looking very good. When you have this scenario, what do you usually do when you have too much information sort of schools? How do you solve this to make this maybe just show the trend but not that granular? The hierarchies. Jeez. I guess you'll be seated on this side and then yeah, but true. Or you can create a date table, a separate one with groupings, then that should also help. But not the focus of today. Just to show that probably I know what I'm doing. Kind of like everyone. So let's see. This point I'm thinking. Total orders. Okay, interesting. Total sales. Fair enough. And just do it one more time and then just see what's up. Displays the products. What's this value? Okay, let's come back here for a minute. Just look at that products table. We're doing all this to get a bar chart and a pie chart. And we shall see what's up. Customers to orders, that's okay. For the items. All right. Let's see. All right. So what was happening? I realized I did not think out loud. It had, due to that auto detection of relationships, it had created a relationship between list price on the order items and the listing prices on the product table. Now the problem that was bringing up is this is going to be, it was doing a one-to-many, but remember there could be duplication. An item could have more than one item could have the same price. So that one-to-many is not even being met. So it was a many-to-many, and then we are not able now to be able to have our relationship between the category IDs. That was a bad relationship. So should be good now. And yeah, not too bad, not too bad. We could try another visualization there. A bar chart.
And also try the matrix.
Matrix.
The matrix is where you got
Oh, like a table.
the other one.
This.
Yes, adjacent.
Yeah. It is just like table for a fact. What is surprising is, okay, it is dummy data, but still, it is very
And the
suspicious.
value should be on the counts.
It is very, very suspicious. The counts?
Count, yeah. Then you can check on the counts.
We're even using our total sales metric. So let's try something else. Total orders. Very suspicious. But it could be that, since it's dummy data, it could be that, but I don't think it's that. So let's try by brands. Maybe insert bar chart, and then have the brands there, and then the total sales there. No. No.
Considering the total sales, each land must be divided for all the services.
So still, it should be good. No. It could be this is what the numbers are. It's just that to us it doesn't make sense. But definitely, then we have the visual. It's the point. That's the point. It's just that. I'm actually surprised right today that it should not be the same. So the total sales are 5M. So let's see. Let's see. Grams and total sales. Okay. We're good now. I think so. I think so. So we start with what? Category name? So now, people who have not seen these data sets are agreeing with the visuals more than myself. Anyway, yeah. So what was happening is you were missing, anytime you have that, it's just one relationship is missing. So we were missing the relationship between order items and the products. Fair enough? So lots of the learning comes here. Good. Then the final one was, what else can we have? Brand. Let's see. How many unique brands? You had 7, 9 or 9. So can just have this somewhere. Again, not. Let's have it there.
Just to mention something about this, we have too much information on these other visual.
Yeah.
You said something.
Yeah.
We have too
You
much
can.
information, you can try something else.
Yeah, you can create. So what happens is it's this granular because we are using the order date from that transactional table. So every single date is going to be a data point here. So what you can do is it doesn't if you're in desktop, you can create a hierarchy from that date. Alternatively, you can create a date table with starting from your minimum date to your maximum date. And then you just have a relationship between that and your order date. So now you will build this visual with your order date that you can go down to month, week, just remove this granular. This is how granular it is, because this is definitely daily. That's why it's looking at that. Yeah. So finally, the brand. Let's see whether we can have pie chart here. Brand name, and then total sales. Wow. Yes, please.
Just a query.
Yes, yes.
Let's say I build a dashboard like this and I want it to update on hourly basis, weekly basis, automatically. Would we be able to show us that or?
Yeah, actually, yes, please. Yes, please. So, 6 visuals, we've done very well for ourselves. So we just save it. So let's save this first. So this come to save, and then let's save the report. Give it any name. Call it bikes dashboard. Okay, so if we go to back to our workspace here, you have the bikes dashboard here, and you have your model here. So here's where you do your auto refreshes. So you'll just where we. So refresh, schedule a refresh. So as long as your data source is being updated, you can just come down here, and then that looks. Show you where we do it. Refresh. And then you just configure a refresh schedule down here. So if you want it daily, however you want it weekly, you can just go ahead and do it. You can get very granular, do it at a time, at a specific time. Maybe time you expect data is already coming, and then you just apply. Same idea even when you're working from desktop. So this is usually on Power BI service. Just access your report and your semantic model, you can schedule a refresh like that. That's a good question, by the way.
Do you think that we want to be progressive? So if you need a weekly report from the same from the model, so you will have the data is repetitive, right? So it is a continuous.
Yeah.
So the weekly report is going to show the full information based on the previous, like last month, data is going to be updated from this month.
Oh, I see what you mean. So you're saying, let's say you want week on week.
Yes.
Then you just play with your filters. Yeah, then just play with your filters, or you write metrics that will be, you'll just have to play with your filters, because even those metrics will have to be informed by something. So is it your max date selection, mean date selection, whatever it is. Yeah. So this is just on the semantic bit, not on the visual bit. This is refreshing your data source and then now updating the whole dashboard as is before anyone interacts with it. Filters, whatever.
So it means you can be able to customize
this.
Yeah, that bit. So you have the only that you have the report that you need to pull from the daily transactions and be able to pull that based on those leads.
Yes, that just displays filters.
Thank you.
All right.
Does Microsoft Fabric allow you to maybe share the reports,
Yes.
maybe schedule for it to be coming to someone's email on a weekly basis?
On a weekly. Now, the scheduling bit, that's a good question. So what you do is, we can export visuals to Excel, but you can just embed a live link to our PowerPoint. What I mean is, from your report here, let's go back to our report.
As you asked her question,
yes,
you can also differentiate the difference between the schedule the reports to subscribe.
Between?
The reports, yeah. And between you subscribe so that at least we are 10 users, but at least you need to at least have 2 or 3 people or 4 people that are able to consume or to utilize that information. Now, the difference between you schedule and you subscribe to that report. As you answer the question.
Okay, I'll come back to you. So here, share. So usually just copy link, and then if you open PowerPoint, and I believe it's open here, Just go to insert a new slide somewhere down, just at the bottom. I can do a blank one. So you see this Power BI option. Let's give it some time. Yes, you can be answering the question. So subscribing, you're talking about for the users of Power BI. Because I feel like those are, let me just paste the link here. And then I just insert. So that's the share link from the file itself. Refreshing, see, refresh and schedule. The differences between the two. Subscribe. A subscription is for any Power BI user or consumer. You as someone who's building the reports, maybe you have a pro license, but someone who's also consuming needs to have that license as well. You cannot just share to anyone the report, like a live report. You link to have it live. You can share a snippet of the report, but it won't be a live report. Subscription is even before you start building. Are we together? I feel like you're lost somewhere.
Maybe
No, let's just start. Actually, it's, and the other question you're comparing it to?
You can just proceed and then.
Okay, so and yes.
Can you collaborate with, let's say, we're working on set a data set like 3 or 4 people?
Yes.
We just collaborate on a single project. We have the same access. We manipulate the filters, the tax queries as we go on.
Yes. Exactly the essence of Fabric.
Can you be able to, like, let's say 2 people have read and write access and 2 people have read access?
Yes.
Is it possible to?
Very possible. Very possible. Yeah. So that is one way you can embed a live link. So now,
If I had different sheets,
yes,
will I be able to see it?
as different sheets. As different sheets, like you can have a slide per sheet. So you see this is page on the individual. So next slide you have your yes. So you if you have a scheduled refresh, this automates. Yes. It is a live link. Yes. So one other way you can share a Power BI report. Go ahead. Okay, cool. Any other queries? Cool. Yeah, that's about it. So this was the final bit. A bit lengthy, given we were trying to. There was a lot of relationships going on, not there, going on here, but that's the final way you can now bring your insights to life. Visualize a SQL query, go to your model, go to your notebook, do your EDA, or build a semantic model, and then create a dashboard like that. And that's about it. So, final thing, if you go now to our workspace, everything that we were doing, remember when I wanted us to see these queries, they weren't popping up, but finally you can see everything in your workspace. From this is our report, that is its model, and then that's our lakehouse there. It has the modeling bits, the endpoint for analytics, the 2 notebooks that we had, and the 2 query files that we had. So everything within our workspace like that. So that's the whole idea. Unifying one data source has done all this. And we haven't had to duplicate it to, it's one location, either utilizing links or however we've gotten to that data. It's been sitting in one place the whole time. And we've done all that from the ML models to some queries here and there, and building a not so good looking dashboard. But That's the whole idea. So, yep, and that wraps up my time. So if we have no other questions, we can proceed to the next section.
The link, because I really want to go through it now.
Oh yes. So it's live on YouTube?
We should also share the link on this slide.
Okay, fantastic. Great, that will be all.
Oh, awesome. So I believe that was a good session. As we let Grace come in, I'm sure some of you have gotten interest in different, data personas. If you are a data analyst, maybe you've also just gotten a gist of what data engineers do. If you are a database engineer, you've gotten a gist of what machine learning engineers or data scientists focus on and what their workflows look like. The whole concept of Fabric is to bring all of these workloads into one platform, just as Nduti said, with unified access to data, unified data formats to work with, the Delta packet files, which you can have your tables and CSV files, etc., which therefore solves the problems that we talked about earlier. And at this point, maybe I can just randomly get, by show of hands, who's gotten challenged by some of the concepts that we've talked about here, and what stood out for you in terms of something that you'd want to learn further. So maybe from that table, what of the 3, 4, 5 workflows, or what was most intriguing to you? Anyone from this table?
Yeah, for me, I think that bit of querying the data using the SQL, and I'm not being used to it. I just have the file or the Excel file is there. Just going to the report.
Yeah.
Now from this Fabric, I think I need to go and practice more on that, because maybe we can maybe get someone now we need to. We're working with the big data.
Yeah.
Yeah. So I think that is one thing that has to be for me.
Absolutely. So in most cases, you find the spreadsheet level data is very limited, and it's not even the most efficient way of storing data. That's why we have databases. And just like you said, we are talking about scale here and the way things are moving. I don't know if you heard of this story around COVID time, where when we used to report those cases per day, and the UK government was storing its cases per day on an Excel file. And of course, Excel is limited, so it got to 1,008,000 rows, and suddenly the whole thing crashes. So it's just the scenarios that you don't want to get yourself to. I was also just reading about a story the other day about, some software engineers thinking, so they have a counter, and I think it's for sales or something. And somebody was of the view that we should add a trigger so that, because this is a 64-bit, container, we should add a trigger so that if we get close to its capacity, we should be alerted that, you're kind of nearing the limits of that counter. Then you realize, like, a 64-bit integer can store, like, if you keep on adding 1 million digits per day, it can still run for another 25 billion years. So we got enough time on that side. But such errors can always occur if you don't use the most efficient tools. And that's why your workflow should enable you to really, speed up what you're doing, churn out the reports that you need to, and focus more on what's the end goal. The so what question that we always ask in data. You can build all these good models, but if you can't answer the business question, then maybe there's a problem somewhere. So all data professionals are important, or all data flows in the data life cycle are critical, and they can leverage tools such as Fabric to just make their work easier, make their work secure. That's something also very big. I know we don't, always focus on it, but like I told you, you're not only analysts, engineers today. Tomorrow you'll be the next CDOs, the next data strategists and data stewards and data governance professionals. And so you need to know what architectures, what workflows would be best for your teams and for your organizations. With that said, I'm sure we covered machine learning today, but just at a high level. Everything we covered at a high level. We covered Power BI, data visualization at a high level. So obviously you've gotten intrigued to learn. And I think that sets us up now for the next thing, which is what other skills do you need within your arsenal to be the best at whatever you do, whichever stack you are in. How do you get yourselves equipped to handle those workflows when they come, and to be more of a full stack data person? So I'm sure it's a question that is lingering at the back of your minds. And for sure, you're in a good place. You're in safe hands. It's Zindua School for a reason. Data is one of the programs that we actually focus on. We have technical mentors. We have programs like these. We have masterclasses, but we also have a lot more. And I think I'll pass it on to the event host to just, brief you more on what that entails. You have a question? Yeah.
Yeah, before you go,
Yeah.
Microsoft Fabric, it's quite a very awesome feature.
Yeah.
Tool, but I've been questioning myself, why haven't I had it before? Then I went and saw online, after you exhaust your free plan, are you paying for 34,000 a month?
Yeah, but as an individual, I don't think I've seen many cases where somebody is using it in their workflow end to end like that. That's why it's more of an organization's tool.
Okay.
So they buy more of licenses.
Oh, so the organization build it at 4,000 a month.
Yes, they say data is the new oil. Actually, an organization's data, when you look at data governance and data management principles, one of the undervalued assets that organizations nowadays have, maybe we are getting more use of them with the LLMs and everything, but one of the assets that are never valued or valuated, one of the assets that don't get as much prominence in the balance sheets, because it's there are challenges with data as an asset, but data becomes your biggest asset if you can leverage it efficiently. I mean, most services we offer in this capitalistic system, it's more about information asymmetry, right? So you go buy something from IBM because they know more about that thing than you do, is it? So arguably, data becomes, for most organizations, the most valuable asset, and spending 34,000 for such, I don't think is a question. Yeah. Any other question? And I like that provocation.
Yeah, more thinking, do you have a recommended path? Because you see from his presentation, from your presentation.
Yes, I think I was
Because
forgetting.
you need to learn one thing before you go to the other. The other.
Yes, there is a path. It actually just depends on your where you're gravitating.
No, it depends because maybe you want to tilt.
So that's why I think initially, and sorry for rushing your question or preempting what you're going to ask, but that's why we learned about data, different data professions. But depending on now, of course, this presentation will come with the appendices, which will highlight for each workload what you can do and all that that's available to you. But when you now look at the experiences, Microsoft themselves, they give you a learning path for their tools, right? But that's fine. I mean, you don't always just want to learn on the Microsoft stack. But it's a good way, it's a good platform to just develop your own learning path. Now, if you want to be a data engineer, you should have a curriculum. You should have a learning path that you've developed. Okay, I need to know SQL. I need to know these orchestration tools, etc. Cloud, which cloud provider am I focusing on, etc. And I think what I've always said is that's where a structured learning program comes in. And that's where boot camps, such as, a school like Zindua school would come in, where you have a defined curriculum as to what baseline level skills you need to have, what intermediate skills do you need to have, with projects all along as you go, so that by the end of it, you've learned the data engineering, stack. And now it's good to know what each data professional does, so that you also define for yourself what would work either in your current role or your vision. Where are you gravitating towards? What are your strengths? Where are they lying? If it's more statistics, thinking about models, etc., maybe we should take data scientist route. And what are you going to learn in data science? So you start at programming, you're going to learn about databases all the way through the statistics and all the way through model deployment and MLOps, right? So it has to be, information is nowadays available everywhere, but the problem is, do you have the right tools to get the lessons you need? And a tool for that would be something like a vetted curriculum, which is what a school would offer. Otherwise, I can just go on YouTube and you could be lost there for 10 months and you don't come out with anything, which is, yeah. But I hope I answered your question. We also do have our curriculums, available to the public. You can just check on our GitHub profile, which will be shared with you, just so that you can get to know, okay, based on my skill sets, based on where I'm my gravitas, what skills am I lacking that I need to get in this journey for me to get to this and this level. Okay, any other question? All right, over to you.
Hi, everyone. It's me again. I think I was here when we were starting. For those who don't know who I am, I'm Grace. I handle community here at Zindua School. Pleasure to have you all. I hope you enjoyed the session. If you are saying that the session was really insightful, neza mkono. All right, all of us. So I just need 3 people who are not camera shy and are willing to give us a testimonial. Tumaino mkono see what. I just need 3. I don't better 5, it's fine. 3 people. Square wagumu. Only 3 people. We have 1 person. I want 2 more. 2 more. Wengine wanaangalia ni kama wanasema yes. I just need 2 more. 2 more. You just explaining how your experience has been. That's it. You're willing to give us a testimonial?
Yes.
Yes, you are. 1 more. I want a lady now. 1 lady to take it for the team. Ama ni volunteer. Kuna mtu anaangalia vizuri. Are you willing to give us a testimonial? No? You're so camera shy. Okay. One more lady, Prudence. Yes? No? Hey ladies, msiniangushe. Msiniangushe. Just one more person. Hey, wananiangalia kando sasa. Yes, I just need one lady. One. Ama volunteer beshte yako. Ninajua neza. Hi. Are you really? No? Okay, sawa. Tutapata wa mwisho as we finish up. So I know you've been on the screen all through. So I'm not going to share my screen, but I'm going to just take you through what we offer here at Zindua School. I know I've interacted with some of you, and some of you just knew about us when you got here. Some people just saw Microsoft Fabric, and they decided I'm showing up, but they didn't know Zindua School was organizing it. But I'm glad that you came. So we have two core courses that we offer, that is data science and software engineering, right? They take 7 months, that if you take it part-time, and 4 months, and 4 months if you take it full-time. Full-time means you're available to come for our classes here in person, and then part-time it's for people who mostly are working or are students, so you join our sessions online during the evenings, and one session on Saturday in person. That is on the core courses. We also have light core courses, which are a little bit shorter. That is, we have data analytics and also front-end development. It's a shorter. It'll take around 4 months part-time and 2.5 months full-time. That is for light core. And then we have other short courses that we offer that take, we have 30-day challenges. We also have 10-week courses. So for 30-day challenges, we have something like data storytelling. We also have something like no-code, low-code, which is coming really soon. We are yet to launch it, but we're going to roll out the waitlist very soon. And then we have specialization courses, which are very niche for people who are already in the industry and they want to sharpen their skills in DevOps, in data engineering, which are coming up very soon. You can join our waitlist. I'm going to share all these links on email afterwards. I have all your contacts, so I'm going to share that as well. And then we have other short courses that I've not mentioned, that is data structures and algorithms, and also product management. Yeah, so that's a sum up of all the courses that we are offering. And then alongside that, we have masterclasses like we've had today. We normally have software-oriented masterclasses, data-oriented masterclasses, and yeah, mostly like that. So yeah, so glad to have you here. I know I have a gift for some of you. Mulikata ku tweet, yeah? See, just do me a favor. Just take a photo with your neighbor and then post sasa tumemaliza, because you refused to post. Only one person posted, and I'm gonna gift him Katona. I don't know who that is. Who's Katona? It's you. A round of applause for him. Thank you. And then I want us to appreciate mzungu wetu wa leo. Yeah? None other than Nicholas. A round of applause for him. Yeah. For those who came late, na hamri late, that guy was here at 8:20, Mazi. 1 hour before the event starts, which is really nice. That's very commendable. And then I was to award the most active student. I don't know who was the most active. Maybe our TMs can tell us who those were. And then I'd love us to also take a group photo at the very end. So usikimbie, we'll take a photo outside. Tukona photographer, so please come. Okay. Oh, and also you can take photos. We have like an Instagram link outside. You can take photos as well. Acha tuanze na wewe because you are near me. So next time mkwe active, nikiambia mtweet mna tweet, single. I have not seen anyone take a photo. Oh, you can see us. Not yet. Done. Thank you.
Most active person is the one in front of Shisa.
Oh, nice. What's your name? Angela.
The one in front of Shisa. There's two. Because it's you. And you're very active. Yes, you have that's fine.
Okay. I just stand on my right. Hey, tunapiga picha. Evidence kwa karatasi. So you greet me with. That's it. Nope. Thank you. Angela, your turn. So don't leave guys, tunachukua photo pamoja hapo nje. Ona watu wangu wa testimonials msikimbie. Do you mind giving us a testimonial? Kidogo tu. Just one second. Is that a yes? All right, to our online viewers, thank you so much for tuning. That was it from us today.